Hospital Reporters, Pride and Dignity, Stop the New World Order. Welcome to HAAWK TV and welcome to this, the 7th Apollo Detectives discussion, directed and produced and edited by Neil Geddes-Ward, and coming here on the HAAWK TV channel. Now, obviously, if you want to go to Neil's channel, you can watch it. It's there in its entirety. I've not touched or chopped or cut or changed in any way the content which Neil has provided, which comes in this video. I'm just adding my commentary onto it as always. And I'm pleased to say we got the return of the old gang, you know, the lads. They don't really need an introduction. They've been on so many times before. We've also got the return of Colin Sougrin, and I'm very, very pleased to say, despite the disgraceful way that he's been treated and the horrible things people have said to him, he is back. And he's fighting fit, I'm glad to say. And well, you know, as far as I'm concerned, you know, if they want to apologise to Colin, and Colin accepts their apology, as far as I'm concerned, that's the end of it. I've said that many times before. But right up till now, I very much protest against the things that have been said about him. Now we have another new member of the team. His name is Rasa Viharii, and he's never been on the Apollo Detectives before. Now, Rasa is a very interesting chap. Firstly, what he says here is very interesting in this particular program about the Apollo moon landings. However, he delves off into other areas occasionally, and that's worth listening to. And these are non-moon related, so they go off topic, but they're also well worth listening to. And I actually very much recommend that when you've watched Apollo Detectives, you go to the link in the description box and you listen to the HAAWK radio interview I did with Rasa Viharii. We didn't talk about the moon, we talked about an entirely different subject. But let me assure you, it is extremely interesting. It's a subject I've focused a lot on this particular HAAWK TV world. And Rasa provides a very interesting insight into it. I assure you, so do go there, please do. Now we're entering a very, very interesting period, I would say, in the realm of space exploration. Now, a couple of days ago, the Orion booster was tested, and NASA decided to test their Orion booster. Now, this is a solid-fueled rocket that is designed to take the Artemis spacecraft into space, into orbit. So it works similarly to the space shuttle. It has a it's like clips onto the side of the main body, and you have like the moon rocket on the top. And they tested it. It was basically strapped down to the ground very securely, and it was ignited and it was driven, and it left a huge exhaust plume that came out at the sides, and the engineers who were working on this did a lot of tests and things like that on it. Also, the assembly is underway now for the Artemis spacecraft. This is the spacecraft which is alleged, supposedly, going to take astronauts to the moon. In fact, it was just delivered. NASA just took delivery of the heat shield, which is going underneath the Artemis command module, which supposedly will be used to allow the command module to re-enter Earth's atmosphere. So similar to the Apollo mission, the Artemis command module looks very like the Apollo one, and indeed it has a service module behind it as well, and it sits on top of the rocket. Now, it's more complicated than the Apollo missions, because it's designed to rendezvous with a space station that's orbiting the moon, and it's been put into a special orbit so it doesn't basically go off course due to the gravitational influence of the Earth as well, because satellites tend to be very unstable, which is why you tend not to get them in nature. You just get satellites on their own. But what would happen is the Artemis would dock with this space station in lunar orbit, and then there would be a lunar module which will detach from that and land on the moon. That is what is said to happen. Now, of course, the Steve Mumblings of this world and all the others are jumping on top of me right now, and they're saying, "There you are, Ben. Look, we can go to the moon because they're doing it now. They're doing it. They're building a rocket. Can't you see it? They're building this Artemis rocket. What are you going to say when that goes to the moon, then, Ben? Eh? What are you going to say then?" Well, I think you should wait and see if and when that happens. Be assured, if and when that particular mission takes place, I will be commenting on it. But I'm not going to go and sit around. I'm not going to sit here saying, "Oh my goodness me, I was wrong all along because NASA are planning a moon mission. I was wrong all along about Apollo." No, that's not how it works. They haven't done it yet. If they achieve it, great, that's brilliant. I mean, it doesn't necessarily mean Apollo was real, even if the Artemis mission was real, but it does mean, of course, they will have proved a point that such things are possible using conventional, non-secret space program technology. But I think we're going to have to wait and see, alright, and that's all I can say. It's going ahead. It seems to be in the advanced planning stage now. They're testing the boosters, they're assembling the rocket, so yeah, we'll see what happens. I wonder if they can do it as quickly as Apollo. We'll have to wait and see. Probably only a few years, yeah. So that is the new Apollo Detectives coming up. I hope you enjoy it. Of course, always go to the link in the description box. You can just watch it on Neil's channel if you want, but of course I will be including my own commentary. So you get this little bit, unlike the talking heads on late night BBC Two movies, you know, where people are sitting there saying, "Oh, shut up and get on with it. We want to see the film." You know the kind of thing. You know the kind of thing I mean. So all right, I'll shut up now, and you can watch the film. So see you later.
Despite the fact that the majority of people still believe that the Americans landed men on the moon more than 50 years ago, the real evidence unquestionably shows that it is simply not true.
And welcome everyone. It's Apollo Detectives. We're back. I am Ben Evelyn Jones, and I'm joined today by somebody brand new who's not been on the show before. But we are joined, first of all, by some people you will be familiar with if you've been on this show, if you listened to the show before. We have Marcus Allen of Nexus Magazine, Jarrah White of Moonfaker. We have the author, Trevor Weaver, who's brought out the most recent book about the moon landings. And we have our esteemed producer and co-producer, Neil Geddes-Ward, and Andrew Chaplin of the Paranormal Peep Show. And we have come back again after being on the first show. He's back. It's Colin Sougrin. So let's come on to the new person. We have a new member of the team, all the way from sunny China, or not so sunny, I'm not sure. It's Rasa Viharii. Welcome, Rasa.
Thank you for having me.
It's great you're here again. Now, you have a very interesting story to tell. Have you actually spoken publicly about this before?
Yeah, I did one other interview about the moon landings before.
Right, you are. I'm sure the listeners and viewers of Apollo Detectives will be very interested to hear this. And it is your statement. So with no further ado, I shall hand it over to you, Rasa. Take the floor.
Okay, I'm just going to share my screen because me and Rasa have privately arranged that I will do the presentation for him. So I'm going to share the screen.
Should I start with my story first before we go to the pictures?
Yeah, absolutely.
Okay. So I was studying astrophysics in America, and I graduated in 1999. And I was actually offered a job at NASA, but I turned them down, and I went to India to study medicine. So that's why I have an Indian-sounding name. But anyway, then later I was in America. I was traveling back to America in 2001, and I happened to be in New York City when the 9/11 happened. And so then, but it was just very shortly thereafter, I saw that a funny thing happened on the way to the moon. And at first, I was a little bit skeptical. I was like, well, we need some solid proof, to go that far. But then what happened was I was traveling around America, and then I was going back to India, and I went to the JFK airport, and they had a full-size image of the man on the moon on the wall in the airport. And so when I saw that image, and I could see the change of a pixelation between the background mountains and the foreground, it was so obvious, so clearly convincing, that because you can't really see it on a computer screen, but if you take a super high resolution and you blow it up to life size, then you can clearly see the different pixelations between the mountains and the foreground. So then I was pretty much convinced at that point. And I've been researching it ever since 2001. And then what happened was the next year, I went back to America, and I was visiting my friend in California. And I'm not going to mention her name, but her sister actually works for NASA. And so I was talking to her about the moon landings. I said, well, what do you think about these moon landing things? And she says, I'm also skeptical. And this is a NASA employee who is skeptical. And so I said, that's interesting. Why are you skeptical? And then she told me, she said, I read through these documents very carefully about this moon agreement. And she said, something in there triggered me. It was like kind of reading like, okay, if we actually send a man to the moon, then it's regarding like mining rights and all these things. And so that's what made her skeptical. Okay, so I've been reading through these moon landing agreements. I haven't found the quote she's actually talking about, but something made her skeptical. And this is a NASA employee. I'm not going to tell her name. But then later on, I came to China 5 years ago, okay, and I'm actually working now. Now I'm working in this what Marcus likes to call the 0 point energy, you know. So that's my field of work right now. And I'm actually working with the Chinese government and with the top, like what you'd call the MIT of China, the top universities. And I'm specializing in quantum physics. And so I know a lot of the people in the Chinese space mission, okay, and I've talked to them. And so they have, I talked to them about the moon landings, you know, and I said, and of course, they said, of course it was a fake, you know, and they have, you know, they have a big map. They have the most detailed surface map of the moon. And so it's very clear, you know, for them that what we see in the LRO photos of the landing site, that's not what's really there on the moon, you know. So I talked to them about it. I said, well, what's the deal? Like, why don't? So they said what happened was there was the second space committee of the UN. You know, China became a member of the UN. You know, the UN space. What is it called? UN.
Space Treaty.
UN. OOSA, UNOOSA is the space organization of the UN. China became a member in 1980. And so the first they've had 3 conferences, the UN Space Conference. And the first one happened back in the 60s, but the second one happened in 1982. And by that time China was already a member. And so they kind of accepted them into the thing, and China had been doing a lot of work with their own rockets and stuff. And finally, by the third UN conference happened in 1999, and China was already ready to really. They had been receiving a lot of help from the European space and from NASA and everybody. And then they were ready to launch their first Shenzhou 1, which is like an unmanned orbit. And so so this third UN conference happened in 1999. And they kind of pulled the China aside and said, look, we're going to help you with your space program as long as you agree not to expose the moon landing. So China agreed, you know, so that's their situation now, is they're getting a lot of help. You know, we're about to launch our first space station, you know. And so like, of course, there's members in the US Congress who have banned China from the International Space Station, right? That happened in 2011, that they banned China from the US the International Space Station. But there's members of the NASA, and there's especially members of the UN, the EU, the European Space Agency, who want to continue working with China, you know, despite of these American politicians, you know. So you know, we're working very closely. In fact, there's two European astronauts training in China to go up with our next space shuttle. You know, so that we're working very closely with them, but we've all agreed, you know, don't blow the whistle on China, don't blow the whistle on NASA, and then we can continue working together. You know, so that's the agreement now. But they all know it's a hoax, right? And so I've talked to them about that, and there's mainstream documentaries here in China that talk about how they faked it and stuff. You know, so it's kind of a comment. So you can almost say that I'm like an insider here. I'm not officially, I'm not working for the Chinese space agency or NASA or anything like that. But I'm very good friends with them because we're all in the same university and we're all like working in the same government stuff. So, you know, and some of my work with the 0 point energy will be applied maybe in future space missions, you know. And I've even met people in the International Space Station, you know, because of my work is involved with some experiments they did up there on the space station.
That's extraordinary.
So that's kind of my story. That's my story. And, so I think with that, is there any questions, or should I jump into my presentation?
Rasa,
I have one question.
There's quite a few here,
You said that in China, the Chinese seem to be rather willing to blow the whistle on NASA because of the having all these documentaries and stuff that they're airing in China. And I just wanted to wonder, do you have anything to say about the about Chinese program? I believe one of the, because it seems to be a two-way street, because I remember a few years ago there was some articles in the Epoch Times, I think it was, with Dr. Q Zheng from NASA. I actually spoke to that guy. He was the NASA guy who said that the first Chinese spacewalk was faked. Do you have any comments on that, or do you need knowledge of this? Or
Can you repeat that? It cut out at the end. The first Chinese what?
The first Chinese spacewalk. Spacewalk. I think it's Shenzhou 7.
Right. What was the question about it?
Well, there was a NASA fellow by the name of Q Zheng who appeared in the Epoch Times saying that the Chinese spacewalk was faked. Do you have any thoughts or comments on those lines?
No, I don't. You know, like I said, I don't. I don't think that they fake anything. As far as I know, you know.
Going back to your photo that you saw, and you said there was like a difference between the pixelations. So just remind me what that. So was this at an airport? Did you say where did you see this?
Yeah, I was leaving the U.S. going back to India in the year 2001, just after 9/11.
Yeah.
And then they had in the JFK airport. I was going to fly back to India.
Yeah.
And when I was walking to my plane, they had the full size, like life size. You know, you can stand next to the man on the moon and you're the same size. And they had that on the wall at the JFK airport.
So was it the classic Neil Armstrong shot, or was it?
No. This was a later with the mountains in the background. I think Apollo 15 or 15.
And what year did they say this was taken? This photo?
Oh, I don't know. I think it was either Apollo 14 or Apollo 15 photo. It was a very classic one of him standing there, and then the mountains in the background, and then you can see the line cutting. You know, where the forescreen and the back screen projection, you know, is very clear.
Yeah.
71 or 72, I think that might.
It's in your folder here, I think. Yeah.
Where I was going with this was basically, obviously back then they wouldn't have had Photoshop, because you mentioned pixels. So I was wondering whether this was to do with kind of like TV image capture in terms of pixels, or whether they would have airbrushed it, because obviously with the pixelation issue, they wouldn't have had Photoshop, so they wouldn't have been able to manipulate pixels in that way. So I was wondering if there was another way, another process where they would have manipulated it. Well,
supposedly, you know, they were using that front screen projection, so you could tell the difference between the background and the foreground.
Yeah.
I don't know if pixels is the right word, but you could clearly see the layering, you know, in the
a contrast
grain
difference.
Yeah. So it's blurred.
Not the contrast, but the grains.
Right.
Foreground and the background.
The gradient,
totally different.
The resolution.
Maybe Marcus could come in here, because he's a photographic expert.
Yeah, it's quite likely that that photograph was one of the original scanned images, because the original photographs were all taken on Echtachrome reversal film. They were then scanned, and the images that we see are those scanned images, which is why the definition would be very strange. Because if it was correct from a scanned image, then all the pixelation should be the same, because it would be a digital image at that point. It's been scanned in. But if there are changes in it, which is what the pixelation would appear to indicate, then that does confirm that there are, let me say, more than one image put together to make one final picture. It sounds as if it's the Apollo 15 Jim Irwin standing in front of the lander with a mountain behind. It's Mount Hadley Delta behind it, if it's that image. And there's certainly a lot wrong with that one. So it was interesting that you actually picked up on the fact that the pixelation was a bit off in that picture. And as you say, you could see it in an image of that size. If if it's more or less life-size, it would be a huge enlargement over what the original image was. So, so it's very interesting that you actually were able to spot it just by looking at the picture in the airport. You know, one would have thought that somebody at NASA might have spotted that as well, but obviously they weren't looking out for it.
I'd like to ask Rasa about what you said. This is not moon related, but you mentioned 0-point energy tests in the Chinese space program, and you mentioned that these systems, if they work, they'll be actually used in the space program. Is that what you said?
Yeah, we have built the first power station, a 10 megawatt power station, which is producing clean energy 24 hours a day.
Is there any? Just wondering, are there any plans to expand it into other applications? I wouldn't mind having one of those in my house.
Yeah, I mean, right now we're just working on powering the Chinese power grid. You know, our goal right now is to stop burning coal as quickly as possible, and also we want to shut down all the nuclear power plants as soon as possible. So this is we're making steps in that direction. We have this new kind of, we call it quantum energy. You know, anytime you're breaking the Newtonian physics, because according to Newtonian classic mechanics, you can't get more energy out than what you put in. So if you actually are getting more out than in, it means there's some quantum phenomenon going on. And I was actually the one who wrote the quantum mathematics. When I arrived in China 5 years ago, they had this machine and they couldn't explain how it was working. So they came to me and I showed them the math. I said, this is how it's due to this quantum phenomenon that you're able to get more out than in. So that was 5 years ago. I showed them the math. And then 2 years ago, we completed our first power station, and it's been running now for 2 years. So now it's, you know, it's a matter of like scaling it down, and maybe we can get it into a smaller unit, and maybe, you know, aboard a space shuttle someday. I don't know, but
this is like a publicly acknowledged program. This is not like a classified defense project.
No, this is classified.
Oh, it is classified, right? I see.
Sure. Yeah, I you know, I'm not allowed to like tell everything how we did it, but you know, it's there, like, you know, and they're not going to be watching YouTube anyway. So
you don't want to go on a bank on that.
Neil, just a aside, Neil, you could. When I mentioned Rasa's surname, you might want to edit that out. Just.
Oh, but his name would be in the credits.
Oh right. Okay.
Probably bleep it if you wanted to and stuff.
Yeah.
Be clear, we're not talking about
I don't want to get you into trouble, Rasa. That's the thing. Well, I don't want to get you into trouble.
It's no problem.
Okay.
Because they need me.
Yeah. So we won't be seeing you at the salt mine soon then. Okay. Should we carry anything else?
I just asked the question. But just be clear, we're not talking about free energy or anything like that, are we? We're just talking about this new type of discovered way of extracting it. Is that what you're saying?
No. This is what we call quantum energy. It means we are using a little bit of energy to drive this thing, and then the energy it produces is much more than what's going in. So we take out of the output, we take a little bit to run the input. So it's producing 10 megawatts, 24 hours a day with no fuel. Rain, doesn't matter on the sun or the wind or anything. This is just a self-looping system.
Feedback loop.
Yeah.
It's on a feedback loop.
Yeah, that is free in a sense. I mean, regardless of the mechanism,
Sounds
it's
like
free.
Using a perpetual motion machine or something.
Well,
maybe I'm hearing what you're saying, but that's what it's starting to sound like to me.
It's similar to, I mean, I know it's a different mechanism, but we had a big scandal over cold fusion. I'm sure you've heard of that, Rasa, and I think the rest of you have as well. In 1989, someone repeated an experiment originally done in 1920, where someone discovered the anomalous heat effect, and Stanley Pons and Martin Fleischmann, the two scientists, called it cold fusion. Well, there's a bit of a story behind that.
That actually happened at my university in America.
Blimey.
But yeah, I mean, we just call it the quantum energy because the only way to explain how you can get more out than in is due to this quantum. And that's my specialty. I've been writing so many papers. And so that's my job. You know, I'm writing papers all day about this quantum energy and all the experiments which are being done in other universities around the world.
I mean, Andy and Neil and I have a colleague called Andrew Johnson, who he discusses the moon landings as well, but he specializes in this particular field because he said basically when this cold fusion experiment was done, there was a massive government media disinformation campaign just to shut it down. So that
and they not only that, they banned, because I know they were in my university. So what happened was those scientists who built it, they banned them from getting access to the materials that they were once using.
Yeah.
Okay. Should we press on with your visuals?
Yeah. I'm
okay.
ready. I'm ready.
So you got the the Van Allen radiation belt image here.
Okay. Well, this is the one point I want to talk about is that a lot of people talk about the Van Allen belt problem, right? But the Van Allen is just one of 4 problems. Okay. The first problem, of course, is getting through the Van Allen belt, and so you know. But if you look at my picture, you have the blue side and then the red side, right? So the red side is just the solar radiation, which is bouncing off the Van Allen belts, right? So that's the second problem, is the solar radiation, and especially on the missions where they landed on the quarter moon, that means they had to go directly through that. Okay, I have another picture which illustrates that, but I'm just saying, like, that red shield, that red bubble which surrounds the Earth, it is you don't want to fly through that, and unfortunately they were, and so that's a big no-no. And then the second one, I have some other things. The third one is I have another picture about this deep space radiation, and so they're talking about this new kind of shielding. Okay, and so maybe we'll come to that later, right? And then the fourth problem is the micrometeorite problem. Okay, so I think we'll go into those a little bit later, but if you can, I have the second picture.
Yeah.
Which comes after this.
Just gonna call that up now.
Okay. So the first image was what you would call a side view, and now this image is a top-down view. Okay. So you can see the solar radiation coming, and it's going around the Van Allen belt. Okay. So I have 2 images here. The top image would be a new moon, right? The moon is on the other side of the Earth, right? And then the bottom image is what we would call a quarter moon, or a waning crescent, right? I'm sorry, a waxing crescent. So there's a blue line I drew between the Earth and the moon, and so that's the course which they took. Apollo 11, Apollo 12, I have a list of all the ones and what angle, because if you want to reach the moon at a certain time, you have to draw a line. Okay, when our ship gets there, the moon will be there, right? So we want to land on a quarter moon. So that's the course they have to take, which is right through that most dangerous radiation point, okay? So that's a big no-no. And so the reason why that they wanted to land near the shadow when the moon is first coming into daylight, right? What do you call the Terminator line? They always try to land as close as they can to the Terminator line. Why? Because that's the coldest time. So the people in NASA, there's people in NASA who knew it was a hoax, and then there's the rest of the people who thought it was real, right? So the people who knew it was a hoax, their job was to make it believable to the rest, right? So that's why they had to land near the terminator line, because if you land farther away from the terminator line, when you step onto the moon's surface, your boots are just going to melt. Okay. So anybody would know that. So they know they have to land next to the terminator line. So I have another chart which shows, you know, the terminator line and where they landed, what phase the moon was in. And from that, you can tell that the angle, the course that they took to reach the moon at that time.
Don't see that.
Okay, so this just comes from Apollo Lunar Surface Journal, okay? And this is from Apollo 10. And here it says, a starry night. When they took the photo of the Earth rise, you know, here it says it was a starry night, okay? So the reason I want to come back to that is, you know, I'm a very big fan of the American Moon movie, right? I'm always promoting it. But I only have one small problem with that, is that he blows off the star subject so quickly, you know? And I don't think the star question is so easy to just blow off, okay? And maybe here Marcus Allen can help on that. You know, I'm not a photographer, but when I was in high school, I took a course on photography and film developing, and one of my assignments was to take pictures of the stars, right? So I slowed my shutter speed down, you know, and I got a nice photo of the stars, and they were moving, you know, because my shutter speed was so slow. And so that's fine. Yes, we can make the excuse like, okay, look at how slow your shutter speed has to be. But you have to remember this. When you're in space, the stars are thousands of times brighter than they are here on Earth, okay? So you don't need to slow down your shutter speed so much to take pictures of stars in space. And you know, especially like the excuse about the moon glare. Oh, the moon glare would block out the stars. Yeah, but what about when your camera is like pointed up away from the surface? Or what about when you're in the cislunar orbit, when you're on the way to the moon? There's no Earth glare, there's no moon glare there, you know. So I think that it's not so easy to just blow off this star issue so much. You know, I don't know if Marcus wants to comment on that.
No, it's an excellent point you make there, because there is certainly considerable evidence to say that beyond the atmosphere, stars are very, very much brighter than they are on Earth, because they're filtered out by the atmosphere. There's a famous description given by one of the SR-71 pilots flying across the Pacific when he turned his cabin lights off, and the starlight was sufficiently bright for him to read his instruments by, which indicates that way beyond the atmosphere, starlight is an impressive covering.
Yeah,
what's going on? Yeah, to actually photograph them. I mean, all the stories that are told when you've got the glare off the surface. Yeah, that's correct. You do. But if you point your camera just a little bit above the surface, you can then expose for the stars. But nobody did. No photograph exists showing that sort of level of stars, which you'd expect. It's one of the things that most people expected from the Apollo program, pictures of the stars, but none of it existed. I mean, there's the Apollo 16 infrared camera, which appears to show something, but it doesn't show them in any great detail.
Does the James Webb Telescope, the other space telescopes, are they taking digital pictures in infrared and other light waves?
I believe James Webb Telescope, they both use CCD cameras to take it. In fact, there's actually some good pictures from the Hubble traveling through, when they travel through the South Atlantic Anomaly region of the Van Allen Belt, they actually have to shut down a lot of the instruments there. And there's some examples of the cameras when they actually take the photographs. You can see it looks like it was taken in a snowstorm and stuff. And this is just the minuscule part of the radiation, you know, where the radiation is the minimal. You know, and think about what's going to be like if you're going to be traveling through the Van Allen radiation belts. I would like to add some 2 cents worth on this whole the sole opportunity to take photographs from the moon, because there's been I remember when I did my astrophysics courses, we actually had a lecture on all the different space-based telescopes and even space-based proposals, for pictures of stars from space, and there are all kinds of elaborate ideas for lunar-based observatories. Like there was one that stands out on my mind was this one telescope. It's actually called a liquid telescope, because they would use, I think it was mercury, to basically create the mirror. So you would have basically, rather than bringing this enormous heavy mirror with you to the moon, you would have basically this pantry dish essentially, and you just pour all this mercury into it and use that as your mirror to for your telescope. And that was one of the ideas that stood out in my mind. There's all these elaborate proposals that everyone has been wanting to do for setting up a telescope on the moon, and you think, well, you would have thought that would have been one of the priorities.
That's right, because all the priorities now, all the money spent on the James Webb Telescope and the Hubble and all these other ones, you could have done that 30, 40 years ago with a few extra gadgets, maybe $100,000 telescope of some sort, and stick it on the lunar surface and get great shots of it from the lunar surface with the Hasselblad cameras or something. But as we say, there was only this infrared kind of telescope put in the shadow of the lunar module on Apollo 16, or whichever one it was. I'll add another image to the gallery, but talk amongst yourselves while that's happening.
Colin, have you got any questions for Rasa? Because I think you wanted to ask a couple of things.
I just wanted to add one thing, first of all, before you can ask your question. But I just wanted to add one last thing. You mentioned the James Webb Telescope. I have to say that compared to the Hubble, the James Webb Telescope is a bit of a missed opportunity because it hasn't been launched yet and stuff, but it only has infrared, I think, ultraviolet cameras on it and stuff, but there's no visible cameras. So Hubble had ultraviolet, visible, and infrared and stuff. So if this is supposed to be the thing that's supposed to replace the Hubble, you'd think you'd have all three of those spectrums, capable of photographing. I'm not saying that the James Webb Telescope is going to be fake or anything like that, but I'm just saying it seems like a bit of a step backwards, a bit of a downgrade compared to Hubble.
Yeah.
Colin, go for it, mate.
Well, he answered exactly because he said exactly the same things as what I said on the first show, where you had the 4 different types where you had to go through. That's why I thought it was complete rubbish anyway. So he's already stated that. You can hear
the
me.
Radiation. Yep, we can. Yep. The radiation.
Yeah, the radiation, the magnetism, the ionizing radiation, the magnetism, the fact you've got the small meteoroids, and the fact that you've got a whole soup of different types of microwaves, radio waves, X-rays, just bouncing around all over, well, zooming around all over the place. They just wouldn't have been able to do it. It would have cooked them.
Did you have a question about Tesla, Colin? I got your voice clip, by the way, but I've forgotten what your Tesla question was.
How are Tesla going to deal with the propulsion issue?
The thrust, that was it, yeah.
Thrust.
You mean SpaceX? Tesla.
The main thing about getting to the moon and you see, we're all talking about how they're going to get to the moon and how they get on and off. How they're going to deal with, do you know how they're going to deal with that problem?
Rasa? Is that dealt with Tesla technology of getting to the
moon?
moon?
Are we talking about kind of thrust, whether it works in a vacuum because there's nothing to push against?
No,
yeah, that's one is a bit of a nonsense one, because when you set up a rocket in space, obviously the thrust inside the combustion chamber is pushing against the inner walls of the rocket, so that gives you your thrust.
It's Newton's third law.
They have an article explaining that coming up to Wallace in a few days.
The flatheads love that one, don't they?
They always bring me started on those goddamn flat earthers.
I mean getting it off. You see, it's the whole point. One thing landing, it's another thing getting off that planet. Well, planetoid.
So you're saying there's not enough thrust to get off?
But according to Elon Musk, he's going to land. He's always next year. He's going to land a moon rocket, isn't it? I mean, it's been saying that since like 2015.
Yeah, next year.
It's going to be next year. Yeah.
Okay. I want to see that one.
Yeah, I would, because he's already sold 2 tickets apparently to 2 people who are apparently going to be passengers for a lunar orbital mission.
Via eBay.
Can one of them please be Sadiq Khan, and can it be a one-way ticket?
Well, originally he was going to be using the Falcon Heavy to send the Dragon around the moon. That was the original plan. And of course, that one didn't get off the drawing board. First of all, the Falcon Heavy was delayed by, I think it was 5 years or so when they finally launched it. He figured, okay, we're not going to man rate this anymore. I'm going to opt for BFR. BFR being the big, I don't know if I can say it on
yeah.
I'll use the polite version, the big Falcon rocket. Of course, everyone thinks the F word is something else. But anyways, the big Falcon rocket is what he was proposing. And now they call it the Starship and Super Heavy. And that was a better idea, because his Starship rocket, he says this will carry a solar storm shelter. He hasn't unveiled the details about it, but I remember distinctly. Here's what happened. He said initially, okay, we'll just have a column of water pointed to the sun. That will be our protection from the radiation. And I must have come down on the guy like a ton of bricks. I sent him various messages on Twitter. He never acknowledged any of them. And I put out several different YouTube videos basically explaining how because of the magnetic field of the sun, the solar particles, they're sent off in all directions. So you have to have the shielding on all sides of the capsule. And he actually appeared at a press conference. I forget which one it was, but it was shortly after he had stated this. He said, I learned recently that the radiation from the sun, they sort of come at you from the sun because they fall along the magnetic field lines. He used my exact words. I have no doubt that he had seen my videos, and so he said we need to have it on 4 or 5 sides, and I made some theories on how he could possibly do that with the weights that he's proposing and stuff. But so far he hasn't, given his own official unveiling as to how he's going to be shooting these things. I have some educated guesses, but he hasn't said anything official about it. And so far the Super Heavy hasn't been very successful, to say the least. They've had all these different pressure tests with the Super Heavy, and they've gone bang, to say the least.
Yeah.
You see, that's what I'm thinking about. It's the pressure ratio. It's the amount of fuel you're going to need. It's going to be the weight of it. Once you're on there, I don't think you're coming off.
It'll be a great opportunity.
To work that out, you would have to use the Tsiolkovsky equation, which is the maximum change in velocity of the rocket. You would want to work that out by basically, that would be the exhaust velocity multiplied by the natural log of the initial weight of your rocket over the final mass of your rocket. That's how you would try to work out how much energy you would need to get off the surface, because you want to reach the lunar orbital velocity. You want to make sure that your maximum change in velocity is within that parameter.
I don't think it's possible.
It's a great opportunity, actually, though, Colin, because I'm sure the magazine will cover this, Marcus, I'm sure, but the more trouble that Musk has with this project, and the more in the design work, more and more people are going to say, well, it wasn't a problem with Apollo, so why is it a problem for you? 50 years later, surely we can meet these technological challenges people did in the 60s.
Well, it would certainly appear that if Musk believes that Apollo was the way NASA describes it, and he's trying to do the same thing, and he's now finding that there are many, many other problems that have to be overcome, he's probably going to get to a position where he will actually have to show up NASA for being the liars that they are. Oh, there we go. Oh, it's a very famous picture, that one.
Yeah.
Apollo 14.
Shadows going in all different directions, yeah. Local light source.
So regarding this picture, there's one guy in Norway. His name is Reidar Finsrud, and he made this like a kind of like a perpetual motion thing where it goes around and around and around. And he's an artist, but also kind of a scientist guy. And he made an official. The Norwegian press came to interview him, and he did a show on the moon landing hoax in Norwegian. Okay, and so he used this image, and he created a scene in his house where he had a little model ship. and the little rocks and everything, and he had the light, and he said this is where the light needs to be in order to create these images. It's a mainstream Norwegian documentary about the moon landing hoax. So this, you know, like Bart Sabrell had made one video where he says this is the ultimate picture. If you can show how these shadows work, then I'll pay. I don't know what he said, but he said this is the ultimate. For me, this is like the ultimate picture. This is so clear proof, you know, of a close light source, right? It can't be any more clear than that, you know. And that's why that Norwegian guy used it also.
It makes me laugh that Mythbusters tried to prove that photograph was taken in direct sunlight and not in a studio by setting it up in a studio. Shay Winley did the same thing.
The main issue with Mythbusters thing was that their argument was that it was the rough terrain that was causing this, but they didn't do anything to establish that it was terrain in the photograph itself. And in fact, the resolution's not very good in this one, but there's a better example on all of some stuff where they're having like a close-up of the shadows on the rocks in the same terrain as the lunar module. That they seem to be pointing in the same direction as the rocks in the foreground. So that illustrated that you know, terrain was not the issue in this case. And so I believe the Bart Sabrell picture you were talking about was one from Apollo 17, in which the shadows were like intersecting at near 90 degrees.
Yeah, that's right.
I forget the number of it, but I did my first moon photo on that particular photograph.
All the Apollo believers who tried to debunk what we're saying have supposedly recreated these images and proved that they were taken in sunlight, but they've all done it by setting them up in studios, so they're kind of defeating their own point and proving that. The only person I know who's done an experiment to reproduce these pictures in real sunlight is yourself, Jara, the one you did with the cardboard box.
Yeah, that's right. I had a cardboard box with the cardboard box was actually to shield the subject from the natural field light of the blue sky, because here on the Earth, a lot of people don't realize this, but the blue sky itself acts as a secondary light source, you know, filling in the shadows and whatnot. Whereas if you were to, you know, remove the atmosphere and stuff, obviously we wouldn't have that light scattering effect, and there would be no field light in that case. So that was what the cardboard box was for. I'd also done experiments, you know, trying to recreate the 90-degree shadow angles that Sabrell, you know, brought to the attention and stuff. And the only way I could possibly do that by perspective alone was if they were, you know, massive space between the two, or if it was with a fisheye lens or something or other, which obviously we didn't have fisheye lenses before.
One question for Rasa. Have you seen the film Make Believe Smoke and Mirrors with the enhanced commentary on it? It's been done by Bob Williams.
I don't know if I've seen the enhanced. It's been many years ago that I watched some of.
Okay, on the Apollo Detectives YouTube channel, which is run by Bob Williams, he's taken that film, 2 hours 44 minutes of it, split it into sections, and actually added the correct commentary, so you can now understand a great deal more about what's going on. And I would say that image from Apollo 14 that you're showing there was probably taken from the set they were using to create the images, but using models to do so, and using spotlights in studios to do it. Because if that model is about 12 inches high, then we're looking across something maybe 20 or 30 foot in terms of studio space. But one light source, yes, it would produce that sort of image, because the light source is just off to the left of the picture. So if it was taken from the Make Believe Smoke and Mirrors film, showing the sets on which they were actually photographed, that makes much more sense. But to say that is real life on the lunar surface is complete nonsense. The shadows don't fall that way in real sunlight. They fall that way in spotlights, but not real sunlight.
Trevor, have you got anything to add? You've been quite quiet recently.
No, I was interested in what Rasa said earlier on about the load of videos going around China about the moon hoax.
I had one to this whole near light source thing. I'll never forget this and stuff because there was that Adam Ruins Everything TV show that came out a couple of years ago or so, when he was arguing that we can't have the use studio light because use studio light the shadows converge and we got parallel shadows in the Apollo photographs, which is complete contradiction to what we actually have, because like this Apollo 14 photo is exact demonstration of exactly what he's arguing against.
Can you hear me?
Yes.
Yeah. Oh, okay.
I can't hear. I don't know how Neil's getting on.
Yeah.
Can you hear me?
Yeah.
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 You're all right
It is
now.
now.
Yeah.
Yeah.
What I did, I unplugged the mic. Thank you, Colin, as well. I unplugged the mic and replugged it. Yeah, what I was saying, previously, we mentioned the Apollo Detectives channel on YouTube. Now, that's not to do with us here as the Apollo Detectives show or program, which is a completely separate thing. They're both obviously talking about Apollo hoaxes, but the Apollo Detectives channel is a channel run by this chap, Bob, who puts all sorts of videos on there. But we are just the Apollo Detectives show on the Neil Pill channel or on Ben's channel, because Ben grabs this as well and puts it on with his own commentaries later. So Rasa, you've got these other images here of the moon taken from one of the Apollo craft, allegedly.
Yeah. Okay. So the last week I was taking a vacation, so I downloaded all of these thumbnail images, and so I scanned them all, and I have a list of like at least a dozen or so bloopers from these. So, but this is just one of them. So this one is Apollo 15, and that is the real 96. Okay. So when you look at the whole, what do you call, look at the big picture, you know, what you're seeing here, what they're supposed to be doing is this EVA, right? He stepped out of the capsule to retrieve the film or whatever. And so that's supposed to be happening on the way back to Earth, right? But if you look at the images that are leading up to this EVA, they're actually getting closer to the moon. So this is just, like I said, I've got a list of like a dozen smoking guns that are like just discrepancies when you look at the bigger picture. Like when you look at the whole roll and you follow it picture by picture and what's happening, you know, they're supposed to be heading away from the moon, but they're actually getting closer to it. You know, this is a pretty big mistake here. So I've got a couple of.
Would the pro-Apollo people say, oh, that's because you're in orbit around the moon and you have to swing around the moon to get the gravitational force to kind of push you back out towards Earth, and so where it appears to be getting closer, that could be one of those slingshot things, you know, that they do in Star Trek.
No, if you look at the shots before this, they were getting further away from the moon.
Yeah.
And then all of a sudden they're getting closer again.
Yeah.
This is just clearly like there's they're supposed to be halfway to Earth.
It would be the telephoto lens that they were supposed to have as well, because I recall they had a wide-angle lens and a telephoto lens. Would it be the telephoto lens?
I doubt that. You know, it was because when you read the description of each picture, you know, they would list that, oh, here he switched to telephoto lens. No, but it's not. When you read the description, it's like, oh, we're halfway to the Earth now, but the images are showing them getting closer. You know, so this is So I found many of these, but I don't think we're gonna have time to go through the whole list. But
what's the film reference for that, Rasa?
Well, the main thing for me still is, when I was doing my 9/11 investigation, one of the things I looked for to find out if there's a nuclear event was to find out if there's any scintillation on any of the images. And there's one where you've got the cameraman who's caught in the dust. You can see the scintillation start on the image and you can see the image disappear. That's the whole point. There'll be so many lines across these images. You would actually have radiation across the image. Because if they're using film, on each one of these, if they're supposed to be using film, as Marcus always says, and as Jared said before, and as you mentioned, there should be at least lines and streaks somewhere. There should be some form of dot, some form of pixelation, some form of damage.
Right. Yeah, that's true.
They're just they're too clear. They're too crisp.
I think Marcus brought this up in a previous thing. I think it might have been an email to me and stuff. But when they did the IMAX film on the space station, they actually had to put the film canisters in bags, or surrounded by bags of water, in ways to try to shield them from the radiation in low Earth orbit. And this is, again, it's minuscule compared to what you're going to be getting in on the trip to the moon.
Well, you can even see it on the live images. If you watch the live video, you can see it every now and then. You can see the video being disturbed. But these have got nothing. They're completely clear, completely crisp, completely smooth. It's just not possible, I don't think.
It's true. True.
There is an interesting video that someone pointed out on Deep Thoughts Radio. I think it was the guy Mark that hosts that on Deep Thoughts Radio, and I can't recollect which mission it was, but it might have actually been the first one, Apollo 11, where and you can compare this today, like the Japanese satellite that goes around the moon with a continuous live feed. You can see that on YouTube, and it's going around its orbit, and the moon's rotating under it. Is that in this particular shot of when they've got to the moon in Apollo 11, they're filming out the window allegedly, and you can see a few craters, but the moon isn't moving fast under them or anything like that. It's just there all the time. It's not moving at all. Now, when you're in orbit around the Earth, and that's either old footage from the 1960s or present day footage of satellites and things, the Earth is moving pretty quickly under you. And so if you supposedly entered the orbit of the moon, those craters would have moved well out of the window frame, and you'll be onto a mountain range or something, you see. So I thought that was an interesting point. I'll see if I can track that footage down for another presentation. Right, I'll add another shot for you there, Rasa. Just bear with me. Any questions whilst I call this shot up for anybody?
Yeah, I was asking Rasa. Can you hear me?
Yes.
Yeah. I was asking Rasa, this sequence of photographs you're shown getting away from the moon, what is the reference for that? Which film reel is it?
This is this is Apollo 15, the 96 reel, okay. And that's 13087 to 13098. That I just took a quick clip of those, but if you look at the whole thing, it's just ridiculous. I find so many mistakes like this.
Okay. Here's the next set of images there, looking similar.
Before we get started on that, I have one thing to add and stuff. This is more of a not really a bit of evidence, but rather a bit of something that I found rather amusing throughout the entire Apollo program. Apollo 10, right, when they were supposedly taking pictures of the Earth and the Moon and stuff. I believe it was Charlie Jute was acting as the Capcom, and whilst they were showing a picture of the moon, he says, "Oh, that's a good picture of the Earth there." And for the rest of the Apollo missions and stuff, whenever they supposedly got pictures of the Earth and stuff, they would always ask, "Hey, Charlie, is that the Earth or the Moon?" I always found that one rather amusing.
Hopefully, it wasn't the navigator. Okay, so what are we looking at here, Rasa?
Okay, so this is from Apollo 16, and again, this is just a sequence of clips. Okay, and so what you're seeing is the LEM is above the command module, right? They had just separated.
Huh.
And then all of a sudden, the command module is many, many kilometers off into the distance. And then all of a sudden, the LEM catches back up with the command module. And again, now the LEM is below the command module. And then the next picture, the LEM is above the command module. So I can't figure out what's going on. This thing is just ridiculous. I can't, it's just crazy. If you look at this sequence, like how the heck would they have filmed that? It's impossible. So I'll just give you the reference number. That's Apollo 16, roll number 113. And I'm looking at 18279 to 18294, and you can just see that the command module and the LEM are just dancing around. It's like, oh, come back, we need a better photo op or something. It's just ridiculous. This one.
Yeah, considering it's got very little fuel, it'd be a bit awkward to keep coming backwards and forwards. It would have to be a highly specialized maneuvers, rehearsed maneuvers, rather than waste time and stuff. Right, I shall drop another image into the sequence. So just bear with me. Just waiting for these images to show up in the viewing folder so I can actually see what they are. Right, here we go. This looks, what's that coming through here? Inside the...
It's like an EVA photo.
Yeah.
So this image was for Marcus Allen, because in one of the shows he said I don't know if it was the camera that was special or the film that was special. Okay, so here in this photo you can see the film canisters sitting there in the vacuum of space. Okay, so they're down in the lower left corner in the white bag. He got several film canisters sitting there. You know, so I don't know how those film canisters can be sitting there, you know, in that freezing cold vacuum, you know.
Well, that's assuming, of course, that they were in the freezing cold vacuum and they weren't at Cinder Lake in Arizona.
This would be on their Mesa table, perhaps, or no?
Yeah,
maybe it's on the Lunar Rover. I don't know which.
It's
like a seat.
It would certainly be true to say that a film exposed like that, because there's no pressurization around it, a film exposed like that on the lunar surface, in the vacuum level that we know exists on the moon, will be totally destroyed. So it's a complete nonsense that they even show an image like that. So either they're very sloppy on their information, or somebody is just trying to say, look, guys, you know, if you know what to look for, you'll see that the whole thing was fabricated.
Yeah. And I wanted to ask you, because you've had experience with Hasselblad before. So maybe if you look at those, I mean, does it have that same kind of a canister when you pop in the film?
The film is in the magazine, which
right, that magazine.
Yeah, on the big magazine, you could have film that will hold up to 200 exposures. The small magazines, which they didn't use, they only used the big magazines, which had 150 to 200 exposures. And they can be separated from the camera and stored separately, so you can change it. But if you start changing the magazine on the lunar surface, you're going to have major problems, and not least with dust being kicked up, because we know there's a lot of dust around, assuming they're on the lunar surface in the first place, which I don't think they are. And those previous images of orbiting the moon and showing the command module and the service module separating and catching up, I think that was done on the big model of the moon that was held at Langley, Virginia. I mean, it was a very persuasive model because it was taken from the lunar orbiter photographs. They showed the real scenery on the moon because they'd been photographed quite comprehensively by the lunar orbiter. And before anybody says, well, they used film as well, which they did, it was all pressurized on the lunar orbiter. You could see these schematics of the construction of the lunar orbiter. The whole thing.
I actually have a video of one of my things I'm going to show you guys later. I actually have video footage, it's simulated, but it actually shows how the film was taken on the lunar orbiter and stuff. You can see how it's all the sealed chamber and the like and stuff. How they quickly scanned it all and transmitted it back to Earth.
Yeah.
There was something I wanted to ask you, Marcus, about the Hasselblad. How did you actually get a hold of that camera in the first place? I remember when I tried to get a hold of the exact camera they had on Apollo, I actually spoke to the guys at Hasselblad. They said, oh, the only cameras we got, they are left on the moon. If you happen to pass by, just pick one of them up.
It was actually being used because it was Hasselblad UK have that particular replica. If you're a television company or you're respectable people, they will lend it to you. And I've seen it twice on two television programs. The one I took the photographs of it on was the first one where Jay Windley does his, well, of course, it was all real stuff. I think that was filmed in 2003. And they produced the camera. The chap from Hasselblad arrives with it in a box. So I said, do you mind if I borrow it, take a picture of it? He said, no, go ahead, which is why I got those pictures. But it's very similar to the actual Hasselblads that you see the astronauts wearing on the lunar surface. which is why it's fairly effective in demonstrating that the camera was not protected. It wasn't pressurized. It couldn't have been pressurized. There wasn't anywhere for it to be pressurized.
But
Therefore,
not only. Sorry, I was going to say, not only that, would that be enough to shield it? Would those canisters be enough to shield them? Because they're just overexposed.
No, it certainly wouldn't be enough to shield it from the sort of level of vacuum you're experiencing on the lunar surface, assuming they were there in the first place. Because if you're going to pressurize something, you have to have it completely airtight, which on the lunar orbiter, it was. You can see the schematics. And on the Hexagon Spy satellite, you can see the same thing. It's a separate container containing all the photographic film. And it was that alerted me to the fact that the Apollo photographs could not have been taken on the lunar surface, not one of them, because the film would have been damaged in the vacuum that we know exists on the moon.
Were they using cellulose?
Sorry?
Were they using cellulose tape? What were they using as film?
Sorry, I didn't get the question.
What was NASA using?
Slide film.
They were using.
What were they using as film? What material?
Yeah, it was Kodak Ektachrome transparency material.
Okay.
Also Kodak Tri-X black and white film. So it was all photographic film.
Okay. Nothing special.
I think you could still get some of it, or maybe not anymore. Rather, I remember seeing it for sale on Amazon a few years ago. It was the ISO 160 type.
Yeah, it's still possible to get it today because Bob Williams did. He got some Estar-based Ektachrome film. It's quite expensive because the development process is quite complex as well. And you can get the chemicals for that, which is what he did. He bought the film, he bought the chemicals to process it, by the book, and got it all correct. And the film was, at the very least, the color balance of the film was shot to pieces. And color balance was affected at the level of vacuum that we experience on the International Space Station today, torr 10 to the minus 6. When you get torr 10 to the minus 12 on the moon, it wouldn't just affect the color balance, it would affect the physical structure of the film itself.
Yeah.
Okay, now I did upload the buggy video, but unfortunately it's not accepting it into gallery there. But maybe you can talk about that, Rasa, and I'll edit in the footage over it later.
Okay, yeah. So this is one of the. I like to bring up points which aren't on the American Moon movie. So this is to me a pretty big smoking gun. Is like. When you look at it's called the famous rooster tail scene. It's when he's driving the buggy and all the dirt is splashing up behind him. That's why they call it the rooster tail. So, but then when you zoom in on the driver, you can see his arms is just sitting there stiff. So this is a mannequin. It's a mannequin attached to a remote control buggy. It's so very obvious that this is a mannequin, not a human being, because they wouldn't be able to keep their arm up, you know. So that's a really interesting clip.
It's an interesting thing because, like, when you're driving on a normal road anywhere, mostly obviously a tarmac road, you would be driving. You know, you'd have a certain amount of experience of driving and be confident to then drive with one arm on a steering wheel and maybe the other arm out the window. Now here they are on the moon, unknown terrain. Very difficult conditions, and it's not even a steering wheel, so it's like a joystick sort of thing. You would have thought that they may have held on to their seat a little bit, or maybe held on to the joystick or a kind of a dashboard or whatever, rather than just putting his arm out like that, wouldn't you? It does seem a bit of an odd one.
Yeah, very odd.
Okay, so you got a Chang picture here?
Yeah, you can pull up the next one. So I just have two images of the Chang. And the reason that I pulled this up is because you can see the splashdown when the pad hit the surface and how much dirt it splashed around that, you know. And if you compare that to like Apollo 11, where it's totally smooth, right?
Right, that's coming through now. Just bear with
Chang'e
me.
3, I would like to add on to that because they actually did some research on this. The Chang'e lander was rather gentle compared to the Apollo, because obviously the engine is much smaller than what they had on Apollo, but they also shut it off at 4 meters above and let it just drop the rest of the way down. So I've read anyways.
And especially if you compare the weight of the Chang'e 3 compared to the LEM is just nothing. It's like a toy. So
the Chang'e 3 came down from the video footage I recall. It seemed to come down directly rather than come in horizontally. That the Apollo lunar module would come in. It comes in at a slow descent at an angle. The Chang'e 3 came down vertically, if I recollect the video footage. What I found interesting about the Apollo lander images, Apollo 11 I've looked at, is that when on the video you hear who is it? Not Armstrong. Buzz Aldrin saying, kicking up some dust, drifting to the right a little, and then they settle down. When they're outside the craft taking all the pictures of the rocks and things like that, I've never seen any trail of disturbed soil that would indicate a pathway of their flight path that might have disturbed that soil before they touched down. So I would expect like a pathway of some sort of disturbance on the soil that would then fork to the right slightly, because he says drifting to the right slightly, which would then come under the lunar module itself as they touch down. But I've never seen any sort of suggestion of any disturbed soil from those thrusters or that engine thrusting down. Just my thoughts. I could be wrong on the science of that, but something to consider.
It looks like to me when I look at the Apollo 11, they just set the craft down on the surface. Yeah. And then they stuck those two little poles under the landing pad. Yeah. Right, because they had to be there.
Yeah, that's right. The sensors.
So let me just say one more thing about this. The Chang'e, a lot of flat earthers say, oh, that's a fake, and they it's photoshopped, a CGI or whatever. So I talked to the people in China about that. I said, and they said, oh yes, of course we photoshopped it because they wanted it to look beautiful, but it's they had to make the Chinese flag more brighter and things like that. So yes, it was photoshopped, but it was an original image, which they just enhanced a little bit.
And this is what I was talking about earlier when you said about the module here being lighter. I was wondering how the Apollo mission would have actually got off the ground, because it's a much heavier module. That's what I was saying about the thrust. Thrust weight.
Oh yeah, it's like the Elon Musk one, SpaceX. Yeah.
Well, the Soviets managed to get some. So I was just going to say the Soviets have had 3 sample return missions and stuff. So it is. So I'd imagine getting the craft off the lunar surface again would be a matter of basically upscaling essentially what the Soviets had done on the sample return flights.
But for the Apollo at the time with the technology?
Well, I don't think the Apollo landed, of course, but I'm just saying I think in concept anyways to get off the lunar surface would launch something like an upscaled equivalent to what the Russians did. Yeah, what the Russians did, yeah.
Yeah.
Marcus, I was going to ask, have NASA actually admitted or said that they've enhanced any of their photos? Because putting devil's advocate's hat on, a lot of the arguments regarding Apollo photos are that, they look fake, they don't look right. Have they ever said that, oh, well, we did it to enhance, and make it look good for people?
Not that I'm aware of. No admission from anybody that I've ever read. As NASA said, oh, we enhanced those photographs so it brought out the flag or it brought out the astronaut. No, none of that.
Right.
The only closest thing to I can remember along those lines was the Buzz Aldrin photograph, in which they said, oh, okay, we just reframed him and added a bit of a blacker bar on top of his head to give it some more visual balance. That's the only thing closest to that. Never anything about changing the lighting or anything like that and stuff, which is obviously what we see in the photographs. We see him. It looks like he's standing in the spotlight, as Bloomberg said. But now that you see the more recent pictures, now they've brightened everything up so you can't see the fall off them.
Yeah,
the darker parts of the surface.
Can I ask you a question of Rasa?
Yeah, sure.
Those photographs you just shown there with Chang, there's no stars. Now, taking into account what you said earlier about Apollo, would you expect to see stars? Yeah.
that I asked them about that. I said, why are there no stars? They said, well, our cameras just stopped receiving data, you know, once we got to the top of the ship, you know, so they could,
Right.
you know, they could, but I don't think that camera can angle up any more than it is, because this is just the tiny little rover who's taking a picture of the lander,
But
right?
you don't need to angle up if you're on the moon. I mean, stars are everywhere.
Right.
Everywhere.
Down
I think
to-
I remember reading that the mothership itself, the Chang'e 3 lander itself, had a telescope aboard. I've seen one or two pictures from that. I forget which stars it photographed and stuff, but there are indeed pictures of stars taken by the Chang'e 3 lander.
Right. There's also pictures of astronauts in Earth orbit with stars in the background. So, but it is Jara asked an interesting question on the last show, like about why the Chinese soil samples are different from the Apollo soil samples. And that's a really interesting question. So some of these questions, I need to go back and talk to them at the Chinese Space Agency about again.
Talking of stars, it's something that I've been thinking of since our last recording, where we were talking about the navigation, and I was talking to Trevor yesterday over Skype briefly about, and he had the same question, that obviously if you got like an Apollo craft going to the moon and they're using their sextant in the command module to pinpoint 3 stars or a couple of stars on Earth or whatever to fix their position, how do they do that when they're just a space probe going to the moon, say? I know that there's a difference of like a time factor, like that Apollo supposedly got there in 3 days. For instance, Chang'e 3 may have got there in a couple of months because they're on a slightly different path. But how do those craft pilot themselves to the moon when you have to use, according to the Apollo theory, a sextant to fix your position against the stars to know where you are in space?
Well, they used the AGC dead reckoning, didn't they? But the question was, why do they need to do this if they can send unmanned spacecraft into lunar orbit?
That's right, because they supposedly sent all these craft to the moon beforehand, so they wouldn't have really needed the input of the command module commander looking through the sextant. They could have just done it remotely from NASA, I would have assumed, anyway.
Of course. You could easily.
Yeah.
I think
Okay.
maybe this. Go ahead.
Go ahead, yeah.
Yeah, so I'm just going to say this is another thing that I noticed quite a while ago is, so this is the Apollo 11 flag planting, right? And so you have 2 different video cameras filming the same event at the same time, supposedly, right?
Mm-hmm.
So when I was watching these things, okay, in one of the films, he just plants the flag and it stays planted. But in another film, he plants it and he has to plant it 3 times for it to stay. So these are kind of some discrepancies that I had noticed. That's why I have these 2 photos, because, you know, they're just reminding me of this flag planting error. You know, so
Well,
sometimes
like
it's good if you get this ability to compare 2 videos of the same event. It's interesting. You'll see that they're actually not the same event.
Yeah.
That's very incriminating into these continuity errors because they're presented as 2 images of the same thing. So obviously,
I seem to recollect the jump salute was another one of those continuity errors, supposedly where you can see the flap of John Young on his pack flap up in as he jumps, but on the actual photograph you can't see that at all. Maybe it's just because his helmet was hidden at that angle. I don't know. But that's an interesting point. With your videos, Rasa, I tried to put in the maneuvering of the craft video, but it's not accepted into this gallery. So again, you can talk about that if you like, and I can pop that over in the edit, which I think was docking.
Let me just come back to that jump salute real quick.
Yeah, sure.
Is that so if you look at the footprints underneath him, okay, he's like, if you look at the footprints, he's like running, and then he does a one-leg jump. Okay.
Mm-hmm.
Which is crazy, you know. So it's like, and you look at the video, he's doing a two-leg jump. But if you look at the footprints, it's just he's like running and he does a one-leg. He lifts off from one leg, which is totally impossible. I just noticed that the other day.
Ah,
So look at
okay.
the footprints beneath him. Okay, so coming back, yeah.
Just one point on that previous image where you've got the two of the flag planting. The top sequence is a film camera, and the bottom sequence is the video camera. The video camera was taken off the lunar lander and put on a pole, and it was then used to photograph the flag planting. The top image, which is of better quality, is actually a 16mm film sequence, which was filmed from inside the lunar lander with a Mara 16mm data acquisition camera. That's why there are two different qualities there. But one interesting anomaly in that is that if you look at the top image where you've got them planting the flag, once they've planted it, they don't touch it again. And if you look at them, some of the later images from that film camera, you'll see the flag is in a completely different position. It's at 90 degrees to the way they planted it. When they planted it, it was pointing straight at the sun. Later on, you see the flag at 90 degrees to the sun, which indicates that somebody touched it. But none of the astronauts were recorded as having touched it. So there's a major anomaly between those two images.
Well, this is the kind of thing you see in cinema all the time. I mean, there's entire websites of people who spot gaffes in movies, and basically, this is proof, I think, that this is a movie. If this had been a recording of a real event, it wouldn't have happened because you'd be just recording what was there.
And also on the film showing the flag planting, the date that is put on the information card at the beginning of the film shows instead of the 20th of July, which is the official date of the flag planting, it shows the 11th of July, which is 9 days beforehand. It's so completely different time.
Yeah. If you look at the version they released on Spacecraft Films, on Spacecraft Films DVD, they actually cropped that
they did.
That footage to the point that the date was hidden.
Yeah, it was. It was hidden. Like they'd spotted it already, but they didn't dare admit it. Chaps, I'm going to have to go now because I've got to go for lunch.
Sure.
So thank you very much indeed, and
thanks for taking part, Marcus.
Oh, that's great.
Cheers, Marcus.
Thanks very much.
Just one question to Rasa. Did you receive my email?
Yes.
Oh, that's good. That's good. It's important you received it, just so you had the information. But thanks ever so much for that, and we'll catch up with the rest of it when Neil and Ben post it later. Sorry I have to go now.
That's okay. Thanks for coming on.
Well, thanks for taking part. That's Marcus Allen of Nexus Magazine. So he's had to leave us now, but much appreciated, Marcus. Take care. Talk again soon.
Thanks, Ben.
Cheerio.
Indeed.
Okay, I'll add another image as Marcus bows out there to the gallery. So, it's going to talk about the docking, and there's also the thrusters on the video. So, yeah, there's a docking and an exhaust, should I call it? I mean, thrusters, I'd call it, but you call it exhaust. If you want to talk about that. Now, what else have we got here? Landing phase. Here we go. Let's have a quick look at that. The landing phase image coming through now. And I think the thrusters thing is something that you've pointed out, Jarrah, where you can see thrusts coming from certain spacecraft, more modern satellites or Soyuz craft, thrusting as they're docking with the International Space Station. You can see the thrusters. But on the Apollo craft, you can't see any thrusters at all, can you?
That's correct. The thrusters, they don't, in the Apollo footage, they don't seem to produce any visuals. Any visual plumes, I should say. And you look at pictures of the Soyuz and even the space shuttle, and they're firing the thrusters. There's enormous white jets shooting out the side of it. And
yeah,
it's unmistakable.
And it's the same fuel, is that right?
Yeah, they both use
Yeah.
the same hypergolic fuels, I believe. They use, I forget what it was right now. So I think it was monomethyl hydrazine, I think. I don't remember at the top of my head. It's getting late now
Yeah.
and stuff, but you can look that up.
Okay. Right. So here we
Yeah,
have.
I
carry on, Russ.
had written the chemical equation on my Facebook, but the exhaust is the CO2, N2, and H2O, right? So of course the CO2 and the N2 you won't see, but the H2O means you're seeing steam. So the exhaust is a blast of steam, right? So that's what you would expect to see, and that's what we're seeing on the Soyuz. So why don't we see it on the Apollo? And there should be, and this is just a tiny little blast, right? The correction blast, right? To correct their position. So it's a tiny little blast, and you get this huge thing of steam. But if you're actually taking off from the surface, there would be tons of steam just billowing out of the bottom, right? So the NASA excuse is that, oh, because since the moon doesn't have an atmosphere, the steam is just dissipating so quickly. Yeah, but why does that?
So you trailed off there. You lost audio.
Rasa,
Okay.
could you repeat that? So the last
The
sentence?
last part we heard was the NASA said that the steam dissipates quickly because you're on the moon.
Right. So then why would the steam not dissipate with the ISS? Right?
Yeah.
It doesn't. And that whole thing also, that same debate about why there's no steam on the liftoff, it also comes back to this, why there's no crater on the landing crater. And it's the same excuse. They say, oh, because the steam just dissipates, right? So I think that, the debunkers like to make fun of us for saying, oh, you're saying there's no landing crater, and it's obvious why. But I don't think that issue goes away so easily, because their whole excuse is the steam dissipation thing, and so it doesn't work. It's here is a clear proof that the steam is not just disappearing. There's just with a tiny blast you can see tons of steam. Yeah. So,
even von Braun and the other scientists were all anticipating a blast crater, buried dug underneath the lunar module and stuff, and suddenly there's no crater.
Yeah, it doesn't work out because the gas will still have a mass, so it still create a crater, whether it's dissipating or not. It's directed. That's the whole point of thrusters, isn't it? They're directed.
Right.
Yeah.
You get a drink.
It has the power to rise to lift that rocket up above the surface against the gravity. So therefore, as we discussed earlier with Newton's third law, there's going to be an equal and opposite reaction downwards in the opposite direction towards the surface of the moon. And indeed, even you hear them saying it, we're kicking up some dust.
Yes, exactly that.
We just get glitter.
When you said kicking up some dust, I actually heard it as we're picking up some dust. In fact, some of the transcripts released in the newspapers at the time actually said picking, not kicking. P-I-C-K-I-N-G.
That's what I thought as well. It sounds like picking.
And yet, if they're picking up dust, well, why is there no dust, stuck to the, you would, seeing what they're saying, you'd expect to see like clogged all over the place. You see it clogged on the windows or on the foils and whatnot, but there's nothing there.
Yeah, exactly. And this is why I said that there doesn't appear to be any dust disturbance or a trail that would follow the path of the lunar module as it came down lower and lower. I would expect to see some sort of disturbance in the soil, so that when they got out and walked around, you could see almost like not a trench as such, but certainly where they disturbed the soil as it's coming closer and closer and closer as it's drifted to the right a little and landed. But there doesn't seem to be any of that in the photos that I've seen. Anyway, so we're looking now at the landing sites of the various Apollo missions on the moon. Is that right?
Yeah. Okay, so this is just a little chart I made where I took the lunar phase image according to what day they landed, right? So then this chart is actually very helpful because it tells you like exactly what course they took. Okay, so like for example, if they want to reach the moon at a quarter moon, then they're heading like 45 degrees away from straight towards the sun, right? And if they want to reach the moon at a 90 degree, half of what do you call the first quarter? Sorry, half moon. I was just confusing. But then you'd have to take a 90 degree course, right, to meet the moon at that point. So like basically, you know, you have Apollo 15, Apollo 16, where they reached the moon at this, where it was halfway. And then you have Apollo 14 and 12, where they reached the moon, where it was in this gibbous phase. And then you have Apollo 11 and 17, where it was still in a crescent phase. So that tells you, it tells you several things. Okay, it tells you the course that they would take. And it also tells you what the Earth should look like from the moon, because the Earth will be just the opposite. So like if it's in a waxing crescent, then the Earth should be in a waning gibbous, right? Or if it's in a waxing gibbous, then the Earth should be in a waning crescent, right? So this is just kind of helpful. I found a lot of discrepancies regarding the shape of the Earth. Okay, when I looked through 9,000 photos, and especially I was paying attention to the shape of the Earth when they're going and when they're coming back, there's so many discrepancies. Like the Earth could not have been in that phase because they were coming back from a moon, which is in a different phase, right? So that's why I made this chart. It's kind of helpful just so that you can get an idea of what phase the moon was in when they were doing these things.
I've got one question, Russell, about this. When you look at the Earthrise photographs, the Terminator is horizontal. I mean, wouldn't we, if you're on the moon, see the same vertical Terminator that we, in the way that we see the moon?
Actually, I have another picture coming later which kind of explains that.
Okay.
Rasa, I don't know if you've watched our previous Apollo Detectives videos, but yeah. Marcus and I also discussed this on the Hapanmo show when I interviewed him. But the Apollo 13 landing site, the Fra Mauro region, at the time that Apollo 13 was due to actually touch down, we estimated it probably on or just over the Terminator. So in other words, in darkness, which wouldn't make a lot of sense, seeing as there's no artificial lights, because it would be completely dark.
Yeah, that's another mistake.
Everyone forgot about it, though, because of the drama of Apollo 13. So everyone forgot about that.
But don't worry if it's dark, because they bought plenty of stage lights, as our next picture illustrates.
Yeah. Yeah, so this is just a pan, right? So they did a 180 pan, and they started off like facing the sun, and then they did a 180 pan, and now they're facing exactly away from the sun, right? But the shot directly before, shows his shadow is completely 90 degree different from the next shot in the pan over, right? So this is just totally like, the only way that I can explain this is that they moved the lighting camera between these two shots.
Maybe it's a composite, again, later on in Photoshop or something. They stitched them together.
No, this is not a composite. This is just two direct shots from a pan. He's doing a 180. He's like snap, 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 snap.
Yeah.
Right? So this is just, it's only like a few degrees difference. His camera moved, right? So the only way to explain that is just they had to have moved the lighting source between these two shots. That's pretty bad.
Okay, another moon and Earth phases here.
Yeah,
by the looks of things.
Okay, so again, this is just an explanation, because a lot of people get confused about this. What should the Earth look like when you're standing on the moon? So it's just explaining. If you're standing on the Earth and you see a crescent waxing crescent, then you should see a waning gibbous if you're standing on the moon, right? And just the opposite. So this is just another. I help, a lot of people in my group get confused about these things. So I just made these simple diagrams to explain it.
I've never heard the expression gibbous before. That's an interesting one.
Gibbous means more than half.
More than half. Okay. Now we mentioned Photoshop, so here's a Photoshop image coming up. It looks like it's the Buzz Aldrin one.
Yeah, can we just go back to that one, Rasa? So when you see the Earth rise with the Terminator horizontal, is that correct?
Yeah, this is correct. Like I said, I have another image coming later which explains it all depends on what latitude you're at. So I have another image which shows what the Earth should look like or what the moon should look like according to what latitude you're at. So they did a pretty good job of that. Like when I checked all of the images, they did a pretty good job of getting the angle of the Earth right and things like that, except for that one image where they flipped the moon, which is totally impossible, I think, Okay. So this is just this is the most iconic, right? The most iconic picture of them all, which I call the man standing under a spotlight. And so, it's so clear, I can't imagine how many people looked at this photo ever since the 1969 and not realize that this is a man standing under a spotlight, right? And so, of course, they photoshopped it later and they filled in all the background, so you don't see the spotlight anymore. But
the official explanation is that it's simply to do with the angular reflection on the uneven surface, like you sometimes get on a beach. I mean, I've never noticed an effect like that on the Earth myself.
I've never heard that one. The explanation that I heard was that we the conspiracy theorists were the ones who edited it. That was the excuse I actually tracked down the original West Australian. You can look at my Moonfaker series. There's one called Posing for Portraits, which I actually tracked down the original Buzz Aldrin photo. We made the front page of the West Australian, and you can see that same uneven lighting is there. So did we invent the time machine too or something?
Oh, that was the next thing they come up with.
I was just writing about that in the book, and I also found the New York Times as well, the same photograph on the same day, showing all the fall off.
Okay, this looks like the Earth from space.
Yeah, so this is just a very early weather satellite which was taking a photo of the Earth, and here it's very, very clear to see the Photoshop work on the edge of the Earth. I mean, this is the magic wand tool where and then you can just cut away, and it leaves these little zigzags where they cut it. So this is a very clear. So I think that there's some times where they purposely try to remove the stars in order to maintain consistency with the Apollo photos.
Yeah, because I've wondered that, like with shots of when you see like the voyages of Voyager 1 and Voyager 2 back in 77, 78 going to Jupiter, and you always saw Jupiter in the blackness of space, but that'd be so quite far further away from the sun and everything. So I've always wondered whether you'd see stars or not, but I just accepted it back then.
I think this is going to become an increasing problem in space exploration in the next few years, in that they're going to have to start looking at consistency. I mean, it's basically what Marcus's the articles in Nexus by Phil Coots have said, because people are going to say, well, how, like, you get a different effect with modern missions than you got back then, and they're going to say, well, why is that? And they had the choices either to come clean or to edit and fake modern missions in some way or another to a greater or lesser degree, just to fit in with the to sort of like to retrofit it with the Apollo story.
They're going to have a problem with a feedback loop with this, because the more lies they create, the more lies they're going to have to cover.
They're painting themselves into a big corner, aren't they? Yeah.
Yeah.
Okay, so what we seeing here?
Okay, so this is so just the last week, I downloaded 9,000 of these thumbnail images, and so what happened is what I think what happened is when they made these thumbnail images a long time ago, before they started photoshopping the high res stuff. So here I just got two examples of the thumbnail compared to the high res. So when you download the high res, you can see it's very clearly been photoshopped compared to the original image, because they've upgraded all the high res images, but when you look at the thumbnails, they haven't upgraded all their thumbnails yet. So you can actually see the silhouetting or the spotlight effect more in the thumbnail images.
They wouldn't be bothered doing those because they just want you to look at the bigger pictures, I suppose.
Right.
Well, I'm just going to bring up the next.
I would like to just get back to that other point that somebody mentioned about no stars in the Jupiter picture. Jupiter itself, can appear, is rather quite bright. It's much brighter than even the Earth here. It says here Jupiter's albedo is about 52%. So that would be about half the light that hits it is reflected back at you.
So they would again adjust their camera on Voyager 1, crank down the aperture a little bit to get it in detail, so you wouldn't see the stars behind it and stuff, presumably.
Honestly, I'd be very surprised if you wanted to take star pictures on the Voyager missions, because it was a flyby, and well, put it into perspective, right? You essentially, you're not orbiting the planet; you're just swinging past it. So you want to get good pictures of the planet. I would have thought that would have been the priority.
Minor correction from earlier, the Voyager spacecraft did photograph stars. They used long exposures to take pictures of the rings around Jupiter, Uranus, and Neptune. As a consequence, there are quite a lot of stars in pictures of these rings. Still, I don't think stellar photography would have been a priority on the outer solar system missions. While Jupiter and Saturn would later get their own orbital missions with Galileo and Cassini, exploration of the outer solar system has been done almost exclusively by flybys. Pioneer, Voyager, and New Horizons, they were all flyby missions. They didn't orbit the worlds they encountered, they simply zipped past them using gravity assists. At best, they'd only have a few hours to photograph the outer planets and all their moons. So in that scenario, I think taking pictures of the planets would have taken priority over the stars. As for the Philae lander, the Philae was landing on a comet. They weren't even sure they'd be able to keep the craft stable because the gravity is so weak. That's why they have all those harpoons holding it to the surface. And when the comet gets too close to the sun, the ice, it sublimates, and so you get all these jets of gas and dust shooting up all over the place. You might remember that scene in Deep Impact where the astronauts are trying to outrun all the steam geysers shooting up all over the place. That's no exaggeration. That's literally what it would be like when the comet goes too close to the sun. So I think the surface of a comet would be the last place you'd want to take pictures of the stars.
Yeah. Okay, so have we seen this one before? It's talking about the physics of space, this one, Rasa, your statement here.
Yeah. Okay, so this is very interesting. I've been looking into this, their proposals for a new kind of shielding, right? So there's three kind of shielding that they're proposing. One is electrostatic, one is electromagnetic, and one is what they call plasma shielding. And so when you read these articles, they're talking about, well, one of them will block out the highly charged negative particles, and one of them will block out the highly charged positive particles, and only the plasma one will actually block out both the positive and the negative. But then it's like when you look at the references, okay, so these are the references from that article. And so what it's saying is, just if you look at the dates of these, this is the authoritative papers written on space particles and space radiation. Okay, and you look at the dates, this is 2004 and 2012. Before these dates, they actually knew nothing about space radiation, because in these papers, they're talking about, okay, you have these highly you have these highly negative charged particles coming from the sun. Okay, they knew a little bit about that in the Van Allen belt, but now they're discovering these highly negative charged particles, which are coming from not black holes, but like supernovas in other parts of the galaxy. So these papers of 2004, 2012 are the actual physics of how supernovas create these highly charged negative particles. And they don't even have, they don't have any kind of a shielding to protect from that. And they didn't even have the mathematics to find out what these things were before 2004. Okay.
I mean, I was just going to say that the Van Allen belts were only even discovered a couple of years before the Apollo mission was started. And
about 11 years, I think, before they were discovered. It was 9 years. It was 1958 when they were first detected by the.
That's before the launches. Yeah, it was only like 2 years later that Kennedy gave his Man on the Moon speech, which means that they'd only just detected these things, and they were talking about sending guys to the moon through these belts. And of course, and then there's these things that there's this belt that Rasa's talks about. So unless you go during a full moon, you're going to be affected by this other band of radiation. If no one knew that then, I mean, when everyone got back, what did they just say? Oh, we were lucky. We were lucky. But it's easy to say that afterwards, isn't it? Not so easy to say it beforehand.
We really did it. It was the Van Allen probes went up in 2012. We really knew very little about the Van Allen belts before 2012.
I mean, the idea is, if they got it wrong, you see, then you'd have astronauts dying in space, and it'd be on TV and everything. I mean, that's unthinkable.
Well, with it only being known 2 years before, they would never have taken it into account with the design.
Yeah, that's another point, because they were already at blueprints for the rockets by then.
Yeah, they wouldn't have made any materials. They wouldn't have even thought of any materials, unless lead.
Yeah, which is yeah. And Megan Hewell instantly said that as far as the charged particles go, lead would just make things worse. She said it's one of that's. Yeah, she kind of just proves her own point, though, doesn't she? Because she said, "Oh,
what's the idea of that is depending on the Z of the material that you're using, Z meaning the atomic number, the higher the Z, the more secondary radiations you get because of the way the radiation actually interacts with the material. Like your electrons are going to produce X-rays as they're stopped or deflected by the material, and the protons are going to produce gamma rays, and of course the heavier particles, like alpha particles. And a lot of people don't realize this, but you see textbooks diagrams showing, okay, the alpha particles are blocked by paper, the beta particles are blocked by the aluminium and whatnot. Well, here's the thing. People assume, okay, if it's going to be blocked by paper, it'll be blocked by the aluminium as well. Well, no.
No,
if the beta particle hits the aluminium, I actually found this out firsthand when I was doing my physics lab sessions. Right? This is part of my astrophysics course. If you have the same alpha emitter and you put the aluminium piece in front of it, what happens is you actually get a much higher Geiger counter reading than you did with the paper piece. And
as more is coming off, you get more material coming off the aluminium as it's being scattered out.
Yeah, exactly, because you're getting the secondaries. It's smashing into the aluminium and it's being fragmented into all these secondary particles. Not to mention you lose all these different particles that the aluminium itself is made of.
And I was actually joking because that is how anti-tank missiles work. By the way, they actually use that approach where they hit the outside of the tank and it's the actual material on the inside of the tank which actually kills everybody on the inside. And that's the reason why they like depleted uranium. For that
You may have been joking, but that's literally the same effect. Obviously, it's a much smaller scale, but it's
I was joking about the lead.
You need different. Basically, you need a different kind of shielding for every kind of radiation. I mean, like with the X-ray chambers at my hospital, they're lead lined, floor, ceiling, walls, doors. I mean, you could feel it when you open the door how heavy they are to protect people outside the chamber from the X-rays inside. But of course, the way the X-ray machine actually works is to create secondary radiation from initial input onto something like heavy metal. I think they use tungsten in X-ray machines. So it's in a sense what Megan Hewell said is disproving her own point, because she said this to try and prove the moon landings are real. I went along and saw her lecture, but fact of the matter is, she doesn't take into account, I think, that by solving one problem, you just create another. Which, again, did the design features for the rocket would have had to have that built in from the very start, because shielding is very heavy. I just mentioned the doors to the X-ray chambers, very heavy. On radiotherapy chambers, they're even heavier because you need more shielding because you get higher dosage.
And plastics weren't very advanced at the time.
Yeah.
There is something I was going to share along these lines. I was going to save it for my presentation at the end, but you don't mind, this might be a good opportunity to actually discuss it.
I was going to say, yeah, if you wanted to say that, Jared, quickly.
Neil, you've gone quiet again, mate. Neil,
I can hear him.
Plug it in and put it out again.
Okay, it should be.
Got you.
Hear me now?
Yeah.
Hear
I
you
was
now.
say we may run out of time for Jared's presentation simply because it's pressing on. But if you want to say what you want to say quickly, Jared, and then we'll press on.
I'll give you a quick little piece of it, a little sample. Okay. Let me just see if I can share my screen.
See Leonid, the first man to set foot on the moon.
Okay, can you see my screen?
I take this
Yep, it's coming through.
Yeah.
All right. Well, basically, there's a new series on Apple TV come out, which is called For All Mankind. This is essentially a alternative reality series in which it's supposed to be a what-if scenario if the Soviets were the first to get to the moon, although they take many artistic licenses. But what I wanted to talk about is here's what they depict for the first moon landing. They depict Alexei Leonov being the first man on the moon. Let me just see if I can play the landing clip. You can probably add this in later on and stuff.
And reflect on what it means for our country and for the world.
It doesn't play this after the fact. We've added the video in and stuff, but basically we got to Alexei Leonov, supposedly the first man on the moon, and his words are, I take this step for my country, for my people, and for the Marxist-Leninist way of life, knowing that there is one small step on the journey to the stars. But what I find particularly interesting about this fictional moon landing is the date in which they choose to land. It's June 26, 1969. The reason that's important, right? We go to this. First of all, here's a passage from NASA's website. This is about the Earth's magnetotail, which is basically the Earth's magnetic field blown backwards by the solar wind. You'll note how the moon actually travels through its tail. In fact, if I can get this other page up here, here we go. This is a quote from Tim Stubbs, who was at the which university was he at? With the University of Maryland. He also works at NASA. Okay, he says here, the Earth's magnetotail extends beyond the orbit of the moon, and once a month, the moon orbits through it. He says here, this consequence, blah, blah, blah. Here he goes. He says, the moon enters the magnetotail 3 days before it is full and takes about 6 days to cross and exit the other side. Okay, keep in mind, he says it enters the tail 3 days before the moon is full. Now, going back to what Alexei Leonov's moon landing was, right, June 26. Right, here is a moon phase calendar. Right, so this is for June 1969. And you see here the moon was full on June 29. His landing was June 26. The reason this is important is because people have actually begun proposing, to use the Earth's magnetic field tail as a natural shield against the solar flare radiation and all that kind of stuff. In fact, I actually got a paper here by Erica Harnett, who's one of the astrophysicists who proposes this. Let me get this paper up. Here she says, what did she say? One potential method of radiation mitigation is in the form of magnetic fields.
Since there are no material interactions, the production of harmful secondaries is not a problem. An extremely important source of magnetic field for the moon is the terrestrial magnetosphere. During the 20-day orbit, the moon traverses multiple magnetic field and plasma environments, from undisturbed solar wind to the deep inside the Earth's magnetic field, the Earth's magnetosphere. So basically what she's proposing in this paper is using, for future missions to the moon, to basically use this magnetic field tail as a natural protection against the solar flare radiation. And well, the date in which they chose to land Alexei Leonov on the moon in this alternate reality series literally is perhaps the most plausible proposal that we've ever seen in any of these works of fictions, because the date, it's literally the date the moon was known to have entered the Earth's magnetic field.
Well thought out. Well thought out.
That's interesting.
They'd have to launch off pretty quick though, because eventually after a day or two it'd move out of that.
Yeah, exactly.
Yes. Also, I didn't know what Rasa said about the heat effects, like the fact the ground gets very hot during a full moon. I mean, I always assumed, going to full moon's best because you've got the sun above you, you've got the most amount of light. But obviously, like that, if that's a problem, your feet get too hot and your boots melt and things like that, then that would be an issue. But I mean, it is odd they chose that date, Jarrett, I must say. I wonder if it was just accidental. Why not just choose the same date as the real moon landing?
They wanted to create this alternate reality series in which the Soviets were supposedly the first to the moon and stuff like that. But I was going to say this in my main presentation, but this series for all mankind seems to have this major identity crisis, because here's a what if, and the Russians have openly stated that Alexei Leonov, he was their man, he was their choice to be the first man on the moon, right? But they have that. They have the Apollo 11 crew as we know them. But then they got all these fictional characters essentially replacing all the historical ones, like the entire Apollo 10 crew. They're replaced with fictional characters. The entire Apollo 15 crew is replaced by. They even got a friggin' woman on Apollo 15 in this TV series.
But they got to be politically correct, haven't they? These days, it's probably an element
rewrite
of that.
history.
When was that paper written? When did she write the paper?
Erika Harnett. He wrote that in 2007, I believe.
Okay, so if she's proposing that in 2007 and they hadn't thought of it at all before that, that's the whole point of a paper, isn't it?
Yeah.
So every time we find these proposals where they're proposing something, it means that they haven't thought of it before, which automatically nullifies that they went.
Yeah.
But exactly, this is the whole point, that they seem to have thought. It's almost like they seem to have almost foreknowledge of what obstacles they were going to reach, and they somehow overcome them, and then they look back and say, well, we were just lucky or we worked it out. But of course, a more plausible explanation is that the missions weren't real.
What's the shadow lengths here then, Rasta, on this? It's like the moon buggy.
That's the LEM shadow. So
the LEM shadow. Okay.
Yeah. So you can see this is you can see that in one image the shadow of the LEM is very short, and the next image the shadow of the LEM is very long. And the only way for that to be possible is if they were on the moon for several days,
as it moves
at least
around.
a week maybe.
Yeah. Well, they were on for 3 days. Which mission was that? I can't see.
That's 16.
16. Okay, because I know the longest mission was Apollo 17, which they were 3 days on the surface of the moon, I believe. But even that wouldn't be long enough for the shadows to change.
No, not at all. This was just like, I think it was maybe the next EVA or something. It was EVA 2, EVA 3, but yeah, it was just a few hours apart. So they must have moved the spotlight. It's the only way to explain it.
Right. Okay. It could be the perspective, maybe. That's only what people might suggest the perspective of the shot is taken. Maybe. Here's another shot of shadows, which I'm going to pop in. Just bear with me. What I'm wearing here. Hopefully this will drop in. Yeah, I think that's going to drop in. He says. Try that. Give me a second. Should appear on your screens very shortly.
Oh yes, this is the descent picture.
So,
Right.
so again, this is just you can see like two people who are standing in the shadow of the LEM. And one is lit up like a Christmas tree, and one is all dark. So that they say, oh, it's the surface glare which is filling him in, but then why is it not filling in the other guy?
Yeah.
Yeah, this is something Marcus has brought up quite a few times. I mean, you can see very clearly also in both images, the background in the sunlight is quite well exposed. It's quite, it's got the same level of contrast. So that's is an anomaly. The only explanation I can think of is the picture on the right has a secondary light source, the one on the left doesn't.
Okay, we've got some shielding things. We've just been talking about that, so that's relevant to the previous discussion.
Right. Yeah, this is interesting. Okay, so the amount of micrometeorites which hits the moon is 10,000 to 20,000 tons per year.
Whoa.
Okay. And the speed of a micrometeorite is 22,500 miles per hour. Okay. So now, like, what is the definition of a micrometeorite? Okay, yes, some of them are very tiny, like a grain of sand, but they can come in all different sizes, to a big rock, So like for example, we know that the Indian lander failed, the Israeli lander failed, probably because they were hit by micrometeorites. I think anybody who actually lands on the moon, they're just getting lucky. It's like Russian roulette. You could get hit by a micrometeorite anytime. Even the ISS was hit by that once. So that's the talking about radiation and all these things. It's the official story is that all these micrometeorites are very, very small, and they say, okay, we've got some of our modern probes have a micrometeorite detectors, and so we can detect a hit and things like that. But again, you're just getting lucky that you're hit by a tiny one that's like a grain of sand. But if you get hit by a slightly larger one, which is going 22,000 miles per hour, and then you look at the shielding. Okay, so this is the official LEM shielding, right? And so they're talking about, okay, we've got these layers, and they've got like 25 layers in the middle, and then you've got the main cabin there, and then you have that outer layer, and it's saying, oh, okay, we've designed it to stop the micrometeorite, right? It's totally ridiculous, It's like that this tiny little like less than a quarter inch, amount of shielding could have actually stopped a 22,000 mile per hour micrometeorite. It's just ridiculous.
You mentioned that you could easily put your finger through the walls of the LEM because the shielding was so flimsy. There is another case with the micrometeoroids that I think is worth mentioning, and that is the fact this was actually happened with the Soviets. When the Soviets had their Mir station, they actually erected the hammer and sickle outside the space station. They put it up on the mast outside there, and shortly after they erected the flag, the Soviet Union collapsed. And of course, they couldn't, make an unscheduled EVA to go get the flag, take it down, put it up with a new one and stuff. But over the time, the flag got gradually destroyed by the micrometeoroids outside the space station. And when they finally went to retrieve it, there was only 2 threads left. And so now NASA is going to tell us that they have pictures from the LRO which shows the flag, the American flag on the moon, is still casting a shadow. They had the lunar orbiter probes. They didn't just take pictures of the moon surface. They also had micrometeoroid detector packages, to measure what kind of bombardment, what kind of damage we could expect, from these from these kinds of meteoroids that you would expect to get on the moon. And you can do the calculations. You can look at here's the hit rate that we had for the Mir station. Here's the hit rate we have for the moon. And you do the calculations, and the flags would be destroyed in a few years. There's no way they could still. There's no way they could have pictures from the LRO. taking pictures of the flag casting a shadow, which they claim to have done.
Yeah, I suppose the Mir station must be a lot thicker than any lunar module, obviously, because it's not required to have a very small amount of weight because it's not needed to land and take off again.
We've only got to see body armor, like for bullets and things like that, you know, or armored vehicles, and you realise that you're dealing with something with, was it 22,000 miles per hour? I mean, that's many times the kinetic energy in terms of the speed and the size as you get from a bullet or a gun shell.
Let me say one more thing about the shielding and the micrometeorites. Okay, I spoke about this this radiation shielding, and they're talking about using this plasma shield to protect from both the positive and the negative. But what are they talking about when it comes to the micrometeorites? So the only way to really protect your ship from micrometeorites would be to make your ship out of diamond. Of course, you can't do that. So what the talk now, all the hype is graphene. They're talking about this multi-layered graphene, which would actually
C50 and C60.
Right. So the multi-layered graphene is, you know, that's the only possible hope of protecting from micrometeorites.
They spoke about graphene before, though. They brought it up in the 2000s when they first started talking about graphene. They started talking about how they could use that as a for exactly that, use it for shielding, multi-layering it. Because I remember doing it, polymerizing graphene.
Again, this is another. This is another problem that people were unaware of when the Apollo missions were being designed. Literally, it was at the start of the space age.
It worked right in Star Trek.
So they've been talking about the graphene idea for a while, but it's going to be extremely expensive to make an entire spaceship out of multi-layered graphene. Might as well make it out of diamond.
Yeah, because I remember seeing that one and the plasma one where they wanted to do a plasma field and create a film of plasma on the outside of the craft, but that one looks just as impossible, really. But that's your field. You'll be able to tell me more.
Yeah, so there's a lot of problems with the plasma shield thing.
The next shot shows a spotlight on the astronaut here.
Yeah, so like I'm saying, like this one, it's like, I'm just pointing these out because these are things a lot of people kind of overlook. So this, like, you can see the shape of the studio light in the glare of the camera. You know,
Oh yeah,
it looks like a halogen
bulb,
light.
can't you?
Yeah, the bulb is sticking out from.
This is not the actual studio light we're seeing. We're seeing like a refraction of light through the lens of the camera.
Yeah, exactly.
Yeah.
So you can see that. You can see that in tons and tons of pictures that this is not the sun's glare, but this is the most obvious because somehow they use the wrong kind of lighting where the bulb is actually bigger than the cap around the.
I remember a lot of people have shown me this photo before, but because they said, "Oh, look, it's a flying saucer.
Yeah.
There were aliens on the moon." But I think it's much more like what you just said, Rasa. It is actually like you see it refracted in a lens. You actually can see through a refractive effect the light itself, which is just outside the frame. And yeah,
Right.
I mean, it is. You see the shade, you see the bulb. It's a lamp.
I was convinced it was Nirabu. You see so many people claiming that they found this planet near the sun. But of course, they're always taking their pictures in the sun, and they get the refraction coming off there.
Don't give Rich Colin any ideas.
Yeah.
Yeah, the only ones you can see it. No telescopes or astronomy.
I'm constantly asked to analyse these pictures. It's funny, of fairies and things like that, and they're nothing of the sort. You know, they're just refractions of the lenses.
So coming up, I actually have the refraction in the lens of actual solar pictures taking in the sun. I have some of that coming up very soon.
Right, here is one, looks like stars when it loads up, so bear with me as it kicks in. I think I clicked OK. Yeah, it's coming in now. Stars from looks like the International Space Station.
That's the Milky
Yes.
Way. Yeah, it's an amazing photo, that.
So beautiful. And you can hear the astronauts on the ISS saying, "Oh, the stars are so beautiful up here." And yeah, I can imagine, you know. Of course, they're going to say, you know, like, okay, well, this was taken in the evening, you know, the sun hasn't come up yet. But okay, so this is obviously taken with a digital camera, right? So the way that they block out stars with a digital camera is they just put a filter on it. But when they're taking these nighttime pictures, they just remove the filter. Right? As far as I wish Marcus would have been here, but this is kind of I'm not an expert in photography, but this is just one of, there's so many. I have dozens of these ISS photos where you just see the stars, so beautiful. The next one also is coming, I think.
Okay, I shall add the next picture. Sorry, Colin just sent me a bit of a message there about the Van Allen belts. Did you want to come in on that, Colin, whilst I'm loading up the next picture? Right, I'm just getting the next shot.
This is Aurora. You see the Aurora Borealis. All of the Aurora Borealis photos, you can see the stars because they're just removing the filter on their camera.
This is a nice shot. Is that a Photoshop thing? Looks
No,
like
this is Google. I think we're on the Google Earth, right? Oh no, this is this is ISS, and then they were in the shadow of the solar eclipse, right? And you can see the Milky Way there. It's so beautiful, and they're coming out of the, you know, their sun is almost pointed directly. The camera is pointed almost directly at the sun, you know. So talking about solar glare, you know, and you can still see the Milky Way, you know. It's just interesting.
I'm just wondering if that is composited from various layers in Photoshop. I don't know for sure.
No, this
might be a telephoto lens, because considering how the moon seems so big in this.
I have a series of these. They took a bunch of photos while they passed through a solar eclipse. It's kind of interesting.
They must pass through solar eclipses fairly regularly on the International Space Station, because they're going around it every 90 minutes. And there's an eclipse happens on the Earth every month or two, isn't there? I believe.
Yeah.
Right. Here's another shot.
I was just going to say, if you wanted to, you could actually make your own your own solar eclipse in space. So it was like back on the Apollo-Soyuz test project, which was where they had the Apollo capsule and the Soyuz, rendezvous and dock in Earth orbit. Now, once they were departed, the Americans, they were nice enough to put the Apollo command module in front of the sun, create a nice little eclipse for the Soviets to photograph.
Oh, I see.
Oh, right.
Yeah, seriously,
Okay.
you look those up. It's pretty impressive. But
It's just as long as it's naturally the moon, anything can get in the way.
Like put your own little shade thing up in front of the sun in space. I mean, there you go. You photograph the eclipse to the art's content.
You don't have the scattering you get, as you were saying, Jarrah. That you do in an atmosphere, like you're saying.
So this
When
shows the
atmosphere,
atmosphere.
you get all kinds of refracting effects, and so ideally you want to take eclipse photography up in space, because you don't have any of these issues.
So what's this one, Rasa? This Google Earth image here.
This is just when you install Google Earth on your computer, they come up with this screen of a picture that the Google Earth satellite took, and I just thought it's interesting because it's almost the daytime here, so coming back, NASA's going to say, oh, well, in the daytime you don't see stars because of the glare, but this picture is it's almost nearly daytime and you're still seeing a lot of stars there.
Yeah.
I'm not sure that's a pretty good example, because with Google Earth, essentially what you've got is you've got image strips. So the way the satellites do, they circle around the Earth and they basically take a scan of the Earth as they're going past, you see. So what you would want to do in this case, you would basically want to take all those image scans and actually put them around a sphere, around a projection, right? Flat Earthers, they love to claim all photographs of the Earth are taken like this, but no, you can find non-composite pictures of the Earth like that. But what I'm saying is that the Google Earth program uses all these different image strips, as part of what you're looking at,
Yeah, to build up a 3D model type of thing.
Exactly, yeah. So I'm just saying, so that would be so what you could probably do in that case would you take one picture of the stars and you'd have obviously your model with all these image strips laid all over the top of it and stuff. And so that would probably be how you would create the Google Earth image there, I think.
Yeah, they could fake it. And also the Google Earth satellite is much higher up, I think, if I remember correctly.
Here comes a shuttle. Hey.
Oh, yeah.
All right. So this is just this is coming to the this was the 1983. This was the first time, in my opinion, this is the first time that they used this PLIS life support. Okay, because before Apollo, all of the spacewalks had an umbilical cord, right? Yeah. And then supposedly during Apollo, the PLIS was ready. We can go spacewalking with this backpack now, and we don't need an umbilical. But I don't think the PLIS was ready in 1969. But this in 1983, I think they had the PLIS ready. So this is, in my opinion, the first time that the PLIS was ready for a spacewalk.
That's the backpack that the astronaut is wearing in that image. It's
right.
You see the same. Yeah, you see the same thing in the a very similar kind of spacesuit in the astronauts on the Apollo missions. But what we've discussed on previous shows about how the PLIS, the backpack, wouldn't be able to do the job.
It's interesting that on the shuttle did have that like a remote thruster backpack that took them right out away from the space shuttle.
It was the maneuvering unit. That was
the maneuvering unit. That's pretty cool.
Yes. They actually switched back to using hoses and umbilical lines after Apollo. When they got down to Skylab, they actually switched back to using umbilical lines.
Oh.
Skylab they did, and then only during the shuttle did they bring back the water life support systems. I always found that rather interesting.
Have they solved the water problem?
You mean for the cooling?
Cooling, drinking.
On the Apollo, it used to be ejected through the heat exchanger. I believe what they do now is they recircle the water back into the spacesuit, and of course the suits now have a vacuum layer, which is built like a thermos bottle.
But they didn't before, did they? Because I'm also thinking about, from what you're saying before, about them landing on the moon, the temperature of the moon, the amount of time they're down there, and water, and the weight of it.
Yes, Rene had a whole chapter about that in his book. I did a film on that, Better Eight Than Never, and you can see the calculations that he did. And what I was saying is that on the shuttle, I think they've actually improved a lot of the problems that they had with the Apollo spacesuits. In that they have a vacuum layer built into the suit now. It's built like a thermos bottle now, and water is recirculated back into the suit rather than ejected.
Rather than ejected out. Okay.
It's a completely different manner of doing like an EVA on an orbiting platform like the ISS or space shuttle, and walking on the moon for 3 days, 2 EVAs or something for 3 days or whatever it is. That's a completely different matter.
And the craft is your only source of water.
Yeah, all you can do is go back to the LEM and refill if you can carry enough with you to refill. If you run out, then you can't do any EVAs because your suit will overheat, or it'll freeze, depending whether you're under shadow or sunlight.
Nowadays they actually recycle their urine on the space station, and you get more water. And keep stock up on your supplies of water.
That's a water cooler I don't frequent.
Yeah, there's lots. There's lots of the astronauts were making jokes about that in the video. Yeah, but it makes sense. You just got to distill it, and it's just the same.
That's where you earn your stripes. This is Surveyor 3 by the looks of things, which is what Apollo 12 rendezvoused with in 1969, I believe.
Yeah. So in the upper photo is the actual photo that the surveyor took of its own feet, and in the lower photos is the Apollo 12 guy supposedly taking a photo of the surveyor foot. So to me, it's just totally different images. You know that
Yeah.
the soil and everything is totally different.
It looks like there's a footprint over a little way to the side of the foot, as if it landed, then maybe moved.
It bounced a bit. Or
Yeah,
something,
bounced and
supposedly.
came down somewhere else.
Yeah. It's interesting actually because we've looked at this surveyor picture in previous episodes of the Apollo Detectors with Scott Henderson, who pointed out on there's actually nothing on that solar array there. And if you look like the underside of it, it looks like there's a glue mark where it's been attempted to glue to its support structure, and they've changed the way that it's actually fitted on. But if you look the underside of that solar array, you can see what looks like a mark of glue where it was previously attached to some kind of another structure of some sort. And I also find it interesting how they supposedly landed only 300 or 400 meters from it. You know, what an absolute goal that was, landing right next to that, you know.
Did you see the camera footage as well from the LEM as it was coming into land? It was incredible. I mean,
that was from a helicopter or something.
Yeah, that was on Bennett and Percy's video. Yeah.
Yeah, that was terrible.
That was supposedly the camera on through the LEM window, and I thought you needed like a proper helicopter camera for that.
Yeah, that was terrible. But I'll add another shot.
So this is my last shot.
I don't remember which one it was, but I remember one of the surveyors actually fired its engines to bounce across the surface, boom, 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 at least once. I don't remember which mission it was. I think it might have been Surveyor 1, actually, but I don't remember which one it was. But I always did find it interesting how they actually, you know, use the same method of landing as the Chang'e 3, you know, cutting off the engine above and, you know, falling the rest of the way down. It was on the pole, obviously. It's always they say contact lights. Okay, we're on the surface now. Engine stop. As soon as they say contact lights, you know they're supposed to be on the surface, but you know the engine should have been drilling into the ground by that stage. Yeah.
Okay, this image is looks like the position of someone on the Earth looking at the different phases of the moon, depending on where they are.
Yeah, so this would tell you, so you can tell what your latitude is by the degree of the moon angle, right? So it would be the same thing for the Earth if you were standing on the moon, you know. So depending on what latitude of the moon they were supposedly standing on, that would adjust the degree of the Earth's angle there, terminator line angle. So I just made this to kind of explain. He was asking a question earlier about how the angle changes, what we would expect to see, you know. So that's why I made this little thing just to clarify. So you would, if you're standing on the equator of the Earth, you know, it's going to be horizontal.
Yeah, I see. Yeah, cool. Thank you. Right. Thank you very much, Rasa, for your presentation.
Well, I still have.
Oh, go on. Yeah.
I still have that one. We skipped that one video, which I think is the most important one.
Okay.
Is it the one with
your desktop, maybe?
I have seen, if it's the video where the LEM is docking with the CM, supposedly.
No. Yeah.
I've seen that one.
It's just incredible. So I don't know if you're going to play that, but
I can put that in later. If you want to talk about it, I can put that in later.
So I'm just going to say that somebody in my group found this glitch, and I forget his name. I could probably look it up, but it was just so incredible, you know, to see that so that is he asked me, what is it? That's a docking radar, the radar which is supposedly helping them to dock with the other ship, and it just falls when it trips over the there's there's something that's holding it up, and then when it turns, it just falls and it droops in the gravity, right? So this is like a smoking gun, and I can't believe that they didn't try to edit that out or something, or they should have reshot the scene or something. But somebody left that in there, in my opinion, as a smoking gun, because this is like, and so the guy who found this, I think he put it on his YouTube channel. And then he got a lot of NASA people criticizing him, saying, "Oh, you did that. You did the video editing. You made it look like it's falling, but it's not. This comes directly from the NASA, and it's not only from the NASA webpage, but also the NASA did a documentary about Apollo 11, and that clip is on the documentary. right? And it falls exactly the same way. So they can't even edit it because now it's permanently part of that documentary, right?
Yeah. I mean, the idea that that some of the mistakes are so obvious that they were done deliberately by people who wanted to maybe get the word out. I mean, this is a core thesis of Bennett and Percy's book, Dark Moon, Apollo and the Whistleblowers. It's perfectly possible. I mean, obviously, I think that's perfectly feasible. On the other hand, it could just be the filmmakers they used, didn't come from the David Lean school, and they didn't maybe have a big enough crew to include continuity errors and editors and all the people that a normal movie production would have. So that's also quite possible, I think. Either way, they must have been very confident of their ability to fool people, just to wow people with the fancy pictures of astronauts bouncing around, so they wouldn't notice these little anomalies.
I think
obviously years later, we're not so emotional about it. We can.
I was just going to say, I think some of the astronauts themselves have even made little tips of the hat in that regard, because I remember in Apollo 8, I think it was Lavelle who said this instead. He says, the moon looks like plaster of Paris.
Yes.
Walking around it and stuff.
I mean, Neil Armstrong, even in one of his first speeches on the moon, he gives tribute to the backroom boys, meaning the set makers, the floor managers.
Yeah.
But couldn't it be just pure arrogance? They think that they've fooled you so much. Look at the COVID thing. Look at 9/11, where they just get lazy. They think, well, we fooled you already. You're stupid enough to believe this. You're not going to look into the details.
Yeah, it could well be, Colin. Not only that, it may even be. I mean, if you go along with the idea that a lot of these people I know this is not all of you will go along with me on this, but are involved in, say, Freemasonry and things like that. There's almost like a kind of belief system whereby it's almost like a karmic thing. They can tell us what they're doing and make it so obvious we have to see it, and then essentially the burden is on us to react, and if we don't, in a sense, it's kind of our fault according to their belief systems.
See, I've been thinking about that. You could have it that side, but it could be that they're just covering the fact that they just make mistakes and they want to look mysterious. We fuck up we muck up sometimes, and we want to make it look mysterious. We actually meant to do that. Because sometimes, look at the amount of research that people have done into 9/11, into COVID, into 7/7, into all these other things, and they start finding gaps, and then they say, "Well, we meant to drop it." No, they could have just been caught. They just made mistakes, like human beings. They weren't expecting people to look that carefully.
Yeah, I mean, it's a common thing that many people do when they're caught out lying. They just say, "Well, yeah, but that was intentional," or something like that.
Yeah, I meant to do that.
Yeah, it's a common thing.
So,
can I throw in one thing?
Yeah, I've got to ask you a question as well, Rasa.
Yeah, a lot of these things I didn't find. I just other people found, but some of them I did find myself. And like for example, one time several years ago when I was looking through the videos, and I saw that famous scene where he jumps up to the ladder and he misses the ladder and he's dangling by a wire. And I thought, okay, that's something that was original. I discovered that. But then later I saw that on American Moon. So I was like, okay, that's cool. But when I first discovered that, my first impression was, okay, this is like a long video. It's several hours long. And they didn't want to just do the whole retake just because of one little blunder like that.
It's also possible they were on they had time constraints, probably not budgetary, but time constraints and things like that. They probably thought, we don't have time to go and reshoot. We just have to put that in there and hope for the best. Hope nobody notices.
Yeah,
that was my impression.
And the more times you shoot, the more chance you're going to get caught.
Yeah, that's it.
Yeah, they seem to be doing things to try to actually limit the amount of footage that they would even have to fake in the first place, because like obviously Apollo 11, they have this grainy black and white thing that's obviously shot for TV screens. It's degraded further and stuff. Apollo 12, guy points the camera to the sun, burns out the Vidicon tube. All we get is basically shot of the ladder for most of the time until they move the camera pointed to the sun. And Apollo 13, near disaster. We've got to shut down the cameras to save the electricity, everything like that. And Apollo 14, the landscape was overexposed, and even on the J-type missions where they had the lunar rover and stuff, they always would only activate the TV camera at certain at the various stations. It was never recorded on the trips there and stuff. Obviously, supposedly they had the film cameras and the like, but film that's obviously not supposed to be broadcast live. You have to develop it and all that sort of stuff. And there's been discussion on it being miniatures and whatnot, which would be a pretty easier way to do it than shooting on location. When we say on location, I mean like on the out where they shot this in Earth in the Nevada desert or whatever. My point is that they found one way or another to try to limit the amount of footage they would have to fake. When you look at all in the chronological sense of all these little tricks they did to try and degrade or lose or otherwise destroy the footage that they would have to fake in the process.
I see this a lot with deceit, with fake videos. Sometimes it's the Loch Ness Monster or Bigfoot, sometimes it's UFOs, sometimes it's ghosts. But they're like, you get like 6 or 7 second clips of something. And usually, and you think to yourself, why is this clip so short? Why did you stop filming? Things like that. And the reason is, of course, is because it's not real. The person has faked these images, but they don't want too long a clip because then it gets more difficult to maintain the deception if it's like a 30-second clip or something.
Yes.
I would like to just add to one thing that you said something earlier. You brought up the Freemasons and stuff. This is a bit of a thing that kind of, I guess, bugs me in a way because I notice many flat earthers in particular, they go around saying, oh, all astronauts are Freemasons, so therefore they're all part of a conspiracy. Well, literally only a small number of astronauts were actually Freemasons. I've actually got a complete list here. Aldrin was a Freemason. Gordon Cooper was a Freemason. Don Isley was a Freemason. John Glenn, Jim Irwin, Thomas Stafford, and Paul Weitz. I think I'm pronouncing his name correctly. But that's literally the only number of astronauts, and only 2 of them, actually 1, 2. Yeah, sorry. So only 4 of them claim to have been to the moon.
I know it was an element that I know you probably wouldn't agree with, and a lot of other people here wouldn't agree with. But you see it. I mean, there's a guy called Mark Passio who talks about this. That it's not necessarily the astronauts who supposedly went to the moon. It's the people behind the conspiracy itself. That is you call them deep state, Illuminati, whatever you want to call them.
I get what you get. I just felt need to point that sort of out because this has just become an obsession that reflects poorly on people now, it seems. Because
not really. Because the whole point is you only need a few people. You only need 1 or 2 people within an organization who have the same goal and have the same ideas, who are able to communicate with each other, and they can keep in line and they can move everybody else. Everybody else doesn't need to know. It's one of the things that they do in computing. It's obfuscation. It's compartmentalization. So the idea that people could be conspiring, and they would have to be conspiring for this to be a lie, still exists. But I mean, how far are you going to take it? Whether you're going to take it to Masons, you're going to take it to angels and all kinds of stuff is up to you. But it definitely shows conspiracy and a group that actually knew what was going on, and they had to be quite high because the whole point is you don't question orders from people who are higher, and you just get on with your duty. And that's the whole point. It's the same thing as what happens, during warfare. It's the same thing which happens in any organization like the NHS, same thing which happens in education. It will be the same thing here.
I found that when you look at the, say what you might call the elite classes of the world, you get a very high prevalence of people who are interested in what you might call the occult, black magic. And I know this is going way off topic for this particular series of programs we're making.
Not really, because if you're talking about physics, if you're talking about quantum physics, and if you're talking about the same scientists, then yes, you're talking about occult.
Jack Parsons, for example, a rocket scientist, he was very into Aleister Crowley. I mean, and of course he was like one of the engineers. They've named a crater on the moon after him, and it's like, I mean, it's a huge subject, Jarrett, and I knew you probably wouldn't go along with me on this, and that's fair enough. That's fine. I just thought I'd bring that in as possible explanation for what we might see as some level of this deceit.
I don't really look into all the occultic side of things and all sort of stuff, but my point is and stuff, I've just seen a lot of flat earthers and whatnot blow it out of proportion and try to make something out of nothing, really. And I feel I feel the need to basically nip this one in the butt before it gets out of hand at times,
Well, fair enough. We did an entire program Well, he did an entire segment of the last program or the one before explaining how the flat Earth thing is nonsense. We went into that.
Yeah, but just because the opposition says it doesn't mean that it's not true. That's the other thing you're going to fall into. That's where you fall into the two-party thing, which most people do. I believe one thing, so therefore you've got to be Republican or Labour. You're doing the same thing. You can't automatically dismiss it because the other side said it.
Could I ask Rasa a question, actually? Because this is to do with, I think we didn't go into it enough detail. I want to go back to the phases of the moon and how or basically the half moon, how it looks from different parts of the Earth. The diagram of the last picture you posted.
Yeah, the last picture.
Is this related to any particular images to do with the pictures taken on the moon of the Earth?
Yeah, I mean, because a lot of people in my group ask these questions like, well, what should the angle of the Earth be? And so from my examination of the pictures, they got that part right. For most of them, they got at least the angle of the Earth right, because they could calculate, okay, we're at this latitude, so this is the angle of the Earth. So I think they did at least a good job on that. But like I said, I have a whole list here of dozens of other mistakes where they have the Earth in completely the wrong phase. It should be waning gibbous, but they have it as a waning crescent. So this is like, I have a whole list of these, but we won't have time to do that today.
Yeah, but again, this I think is another example of mistakes that were put in either deliberately or just out of, like I said, just continuity errors, which they assume wouldn't be spotted. I mean, when you look at like Hollywood movies and things like that, I mean, I look at them and some I like, some I don't. But I mean, when you go online, you'll find there's entire websites, entire cottage industries of people who will pour through every single frame of these various movies looking for errors, which of course is fine. I mean, I think that's not the sort of thing that entertained me particularly. But basically, we're looking at just another example of that, but it's far more serious because this is something that's being passed off as something real rather than fake.
I'm afraid we're going to have to wrap up, gents, because we've gone past the 3-hour part on our recording, although it will be edited down.
Where's Jared? Is Jared gone?
I think he's still here. I think if we can do Jared's presentation in our next recording, which will probably be August, I hope. Thank you, Rasa, for joining us from China. Anyone a final say-so before we wrap up?
Nope.
I just wanted to. It's been a good show. It's been great. It's been different this time. We've had a new member of the team, Rasa, and he's presented
I really want to thank you guys for having me. And like I said, I've got a lot more things I could talk about, but I think we did a lot today.
Cool.
And,
Well, thank you for taking part. We appreciate it because I know that you're a busy man.
Just one question.
Yeah, go for it.
Are you thinking, Rasa, of putting all this down in a paper or a video? Or, I mean, I found some very interesting things that are going to go in my new book. But perhaps I should contact you directly, I think.
Yeah, I was thinking, in the future. I've been working on a Chinese website, like writing it in Chinese. Like I said, most Chinese people don't even know that a human being landed on the moon. But it's kind of I like talking. I've been working on a couple other books, so let's see. Maybe in the future I'll also work on something just specifically on the moon landing.
Yeah, just don't write it in Chinese for us.
Definitely not. It's been really interesting. We've got some brand new material from Rasa. We've gone over a lot of new things from the other regular guests as well, and the other regular contributors. So I want to thank all of you, and Trevor Weaver, Colin Sougrin, Jarrah White, and our producers, Andrew Chaplin, Neil Geddes-Ward. Thank you very much. I hope I haven't left anyone out there.
Marcus,
Marcus has left us now. He's had to go, but he was here earlier on the show. So thank you, all of you. I look forward very much to our next meeting. The quest of Apollo detectives is continuing. and it will not stop until the truth is out.
Okay.
I'm Ben Emlyn Jones. Thank you very much indeed, and good night.
Good to be here.
So that was Apollo Detective 7 there, and that was, well, Neil's giving them numbers, I haven't particularly, but that is actually the 7th Apollo Detectives, and there will be an 8th coming up soon. I'm curious to see what that will be like. Only Neil knows that at the moment, but rest assured I will be taking part. This is something I'm now involved in, and I intend to continue being involved in. So thank you very much, Neil Geddes-Ward, for all you've done, and Andy Chaplin, your co-host, and also all the panel as always, especially the new guest, Rasa Viharii. Thank you, all of you, and I hope to see you all again very soon on future panels. And of course, you HAAWK TV viewers, thank you for watching. There's a lot more coming up. I've got more videos planned for the coming week, so stay tuned. Hospital Reporters, Pride and Dignity. Stop the New World Order.